Well, hello again. Seems like just yesterday I was here. So we're back. Might get some different people this morning as well. You never know. Different time of day. Last night's stream was actually quite good. It got up to like 50 odd people, which was pretty good for me actually. No, it's today? Oh, okay. Twice in one day then. There you go, even better. Let's give people a chance to get here, then I'll get into it. Just watching the post bag. Oh, right. Is that the one for... Oh, I need to schedule for tomorrow. That one. I should really schedule that, else I'll forget. Let me quickly go and do that now. Always scheduling mornings, so kind of need to do that. Otherwise, I will forget. They want to be going. You know, why is there no mailbag out? Let's quickly do this. Won't take me long. Done it before. I've been laying in bed going, hold on a minute, I didn't schedule my mailbag to go out. It's happened more than once. Well, other videos even, not necessarily just a mailbag. Right, that is now scheduled. Mailbag is now scheduled for tomorrow. Well, tonight, tomorrow. I don't know what time it is where you are. Could be any time. Hey Peter, Roran, so Anna, bit of hobbyist, all again, Dave, Sven, at least it was there half an hour ago, Moore, English England. Long time since you twice in a day, yeah. We won't go there. So I had a bit of a look at that power supply we were working on 9 hours ago, and I found another fault. I'm sort of on the fence about whether I should continue with it or not. I mean, like last night I was basically saying, no, that's it. And what I've quickly found this morning, after just sitting down, having a look, I found a transistor which is blown, and the thing is I don't know what it is because the top of the transistor is blown off. The top of the transistor is gone, so I don't know if it's an NPN, a PNP, a MOSFET. It's probably a BGT, but which one? I could just shove one in there and see what happens. What could go wrong? Yeah, so I did find that little surface mount device, but I'm thinking I'll just take those good capacitors back out of it and use it for parts. That's war wheel I'm thinking, because it's not like it has to work. It's just a power supply. It's just a nice thing to play around with, see if we recover it. Yeah, well, that's what I was looking at. Is the Anna? That's what I was looking at. Is this little transistor? I'll show you on camera soon. I'll give everyone a chance to get here. Cars. It's quite close to the capacitor blew up. So I was actually looking closely at that circuitry because there was still some staining on the board, like soot staining, you know. So I gave the area clean, and then when I finished cleaning it, I could see that the top of this transistor was gone. And there's some staining as well on a couple of little surface mount caps. They're not shorted, but the transistor is shorted. So I'm guessing it got across into that circuitry and popped the transistor. There's also another resistor there with like a burn mark on the end of the resistor, a little small one. So barely readable writing. Looks like it's a 8201, so 8.2K it's like, but I'm not sure if it is or not. But so there's a few things there which are wrong. Definitely a bad transistor, but I don't know what it is. So it's only a power supply. If it's just that hole in the board where it's been arcing, and that could be, like I fixed last night. If that's all it was, then it's alright. I would have been comfortable using it. But right now it's like, well, if it's after crossing to the other circuitry and started popping bits of the other circuitry, it's like, what else has it done? Well, there's quite a lot of circuitry in there. There's quite a lot of discrete componentry, so it's like, I'm not sure why it's so complicated. I know it's got this power supply. I did a quick look at it this morning on the actual, just try and get a price of it, find out what's worth. A working one would be brand new. It's $250 US for one of these power supplies, and apparently it's got short circuit protection, overload protection, reverse polarity protection, all sorts of stuff built into it. So it's probably all part of that sort of sensing circuitry. It's something to do with that, I'm guessing. It's got all these protections built into it, so yeah. Anyway, that's what it is. So I think I might just show you what damage I found and then not bother any further with that one. I've recorded some more video on it this morning, just showing it. So when I do the final video, proper edited video, this will be in there as well. But yeah, we shall see. So we'll work on something else instead. So that power supply, I think I was going to be like, nothing I'll bother. Yeah, and we'll do something different. I've got more things behind me we can work on. I'm not short of things to work on, so let's close the app. This app tends to cause my computer to play up. I better close that one. It didn't detect it burning itself, holding itself. No, it didn't have localized circuitry thermal protection. Yeah, that's the only thing it didn't have. Oh, I'm too hot already. It's 8 o'clock in the morning, it's already too hot in here. Anyway, so well, I don't know. I'm not sure what I'm going to play with next. I could go to the thing that's on the top of the pile. Well, actually, not quite the top of the tile. The second to the top of the pile. If I turn this way, maybe you can see it. So, I was looking at this yesterday. I was showing this a while ago in a video. Can you read that? And I was using it yesterday when I was trying to diagnose the GPIB issues I was trying to work through. It's a little GPIB tester, little screen on it, but the screen has got some issues where it's like linking segments together. So like the 2 and 3 look exactly the same, that kind of thing. 8 and 9 look exactly the same. So unfortunately, all the chips in here, they've all got these vague markings on them. I think there's only one there which has got something which is sensible, like 74LS something or whatever it may be. So all the other ones are like custom codes. So I don't know what they are. I've had a quick look to see if I can find a circuit diagram for it. Can't find one. That would be really helpful to try and determine which segments are being driven from what part of a chip. I mean, it could just be as a short on the board, which I haven't identified, but I'm thinking it's likely a chip has gone. Just a minor thing. I mean, it still works. It's just that it's messing up digits, so it makes it harder to see. So you got the first 2 digits. The second digit has got 2 segments which merge together, and was it the 3rd and 4th digits have got 2 segments which come on when you first turn it on, I was going to show you, but there's no batteries in it. And then they, as you use it, they get dimmer, they fade out and basically disappear. So again, it makes it a bit harder to use. So I mean, it's a shame because it's a GPIB test, and right now that'd be really handy to try and see what's going on with my gear when I'm trying to get this Agilent Advantest working. So yeah, unfortunately, I can kind of use it, but I had it apart yesterday and we soldered every single solder joint on the circuit board, just in case that was part of the problem, but it wasn't. "13 minutes behind. No ability to go cleaning." Well, I sewed it all apart, and what it's got is some little fingers cut, and actually the display is like a glass display, like LCD displays they are, and it's a plain glass display, there's no ribbons or anything, and it's got these metal fingers that come up which go to the circuit board, and they kind of clamp onto the display. So these fingers aren't actually attached to the display, they're just touching it. So I cleaned all those and moved them around a little bit and that sort of stuff, and it didn't help. So, but it looks like as well, when it is running, as though it's overdriving the display a little bit, the voltage, because some parts are like oversaturated. And if I turn the power off, there's also like a little annunciators on there, and when I turn the power off, it fades off, and I don't know, it's really hard to explain, but in between fully on and fully off, there's a part there where they're really clear to see, and then they're gone. But so it's like they're being overdriven. So I think there's something wrong with the chip. I don't know. Circuit diagrams. If someone could find a circuit diagram for the Reculdano 488, that'd be great. Hey Christian, yeah, I'm looking more tired now than I was before. Yeah, I got about 6 hours sleep, but that's fine. It's the way it is. It's too early. I will wake up when I'll start blowing things up or something, or putting capacitors in backwards, you know, something like that. I know Ian actually has a GPIB tester, and a while ago he said, "Oh, I'll send you one," because he had one, and one that she designed, and he was. He said, "Oh no, I'm going to hold off because I'm going to redesigning something on it. It's changing something on the design, and so I don't think it's got around to it yet. So I don't think he's actually got back to finishing that design off. So he hasn't sent me one yet. So unfortunately, that hasn't happened. If he'd done that, then I probably would have had a backup, and you always need a backup. But I don't know." It's not Monday morning, it's Sunday morning. Sunday, not that fired. Hey John, fortunately I can't understand what you said, and I don't think I can translate that on here. No, there's no translation. That's annoying. So, hello anyway. Called a pet. Okay. Well, when I was looking for the GPIB stuff, there was other units. I can't remember who made them now. It might be Reculdano as well. It could be HP. I can't remember. But it's got these switches and everything on it as well. And yeah, I mean, I think those were quite expensive, and this was cheap. Now I know why. But yeah. You found the user manual, yeah, the user manual's out there, but there's no circuit diagrams in it, unfortunately. So I haven't actually read the manual. I've just tinkered around and sort of figured out how to use it, because it's got like a memory function on it, and you can step through. So when you send a GPIB command, it may send several sections, and you can actually step through each one and see what each one was, like each character. So when I was doing this yesterday, I was trying to send a read command to my R6581T. And so I'd send a read command to it, and the meter wouldn't respond, or it'd beep. So I thought, okay, let's see what's actually getting to the unit. So I used that GPIB tester, and I could actually see the read command go R, E, A, D, question mark, right, on each step. So you can see exactly what's being sent to it, and then you can also see what's being returned from the meter as well. So it's good for that. It's very tedious. Hi all, is that what you said? Okay. Commodore PET external bus is GPIB. Is it really? So yeah, but I mean, it is just something which you could easily modify now and just do in an Arduino. You know, parallel interface. It's got obviously command line flags. You know, those individual dedicated lines. So you could pick up all those and just use an Arduino to convert it, which I think basically is what Ian's done with his version. So I have to ask him again. Hopefully he pops up today, and I'll ask him. See if he's finished that revision of his design. IoTech analyzer. Yeah, I did see an IoTech one. It wasn't cheap. It was like, what was it, about $1,500 I think on eBay. I looked yesterday just to see if there was anything around which I could possibly buy. Just a, you know, this one works, but it's not great. I'd like to be something better, but so I was having a quick look. It's like, oh, that's expensive. So yeah, some stuff around, but I don't want to pay that much money for something which just sniffs the GPIB bus when I could probably design something and make my own version, you know. Now I could literally just get a GPIB cable, plug off one end of it, so I've got a flying lead, run that into a box with a controller on it, and just plug it into the bus and sniff the bus. You know, it could be as easy as that, but obviously designing it, and I have to reverse engineer the protocols a little bit. Obviously it's really well documented, so it shouldn't really be an issue, but you know, it's something I could do. Whether I want to do it is different matter. I'd rather just buy one. Although yeah, the cost is, you know, that's why I got this one, because this was cheap. It was like, I think I paid about $300 for it or something like that. It wasn't that expensive, well, relatively, compared to what else is out there. It's cheap. Dyslexia, I can't say dyslexia. Yeah, that'd certainly make it hard to program stuff. Yeah, considering it's got to be exactly right, and swapping a couple of things over would be problematic. So yeah, I can certainly see why it'd be a hindrance. The driver chipset's getting expensive. Yeah. Thing is, that's only got to sniff the bus. It doesn't actually have to transmit onto the bus. So all I could really need to do is have a parallel interface hooked up onto the bus. So it's just looking at it. Won't really need a driver for that, I don't think. No, because the driver's obviously interpreting it, then converting it into a serial stream or something. I don't know exactly, but so you know, I think some of that could easily do it. But I don't know. So I have to ask Ian if he's got his revision done, because that'd be really convenient. Because if I could just get one from Ian, that'd be easy than building one myself. I mean, I could build one myself, but that's a lot of time investment. I don't have the time for that. Yeah. So that was what was on the top of the pile, which I was looking at before. So I've now moved off the top of the pile. The next thing on top of the pile is this. Can you see it? Maybe you can. I have calibrator. It it actually works. It doesn't need much. It just needs a little bit of refurb. So this will be something which is really straightforward to do. So it does work. I've tested it. The output is correct. So I've actually got the RF calibrator. I've got, so this is the output, so 30 megahertz I think it was, and yeah, I've got a couple of different Boonton ones. So I've got the RF calibrator. I've got the DC calibrator. So I can check it with the robot, with the try and string a sentence together. Jeez. I can test the RF heads for accuracy, and I can test without the RF head the actual the RF meter itself for accuracy as well, because that's got the plug that goes straight into the unit, which basically simulates one of the RF heads. So it means I can check these things for accuracy, which is good. But yeah, just one of these little tools which sometimes, a couple of times I wished I had them, and I saw them come up, I thought, right, I'm getting one. I was watching for a while for one of these come up at the right price. It still wasn't the right price, but it's close to the right price. They're not cheap. So, but this one needs some refurbing, and it's also got, I don't know if you can see it on camera there. See that dent on the transformer? I want to get that out. Anyway. What else am I missing here? Let's go and look at the GPIB books here. Saying it was straightforward because of death. Yeah, that's true. Could easily jinx it. So the 6848 IC and the, okay. Yeah, because this has got like this record data unit here. I don't remember what the numbers were on the chips, but I looked at them thinking, I don't recognise any of these numbers. So there's only one chip I actually saw a number on it which looked normal. All the rest looked custom. Because it's got like memory and things like that on it as well. So obviously his main microprocessor's got something going on there. So I don't know. I shall. I wanted to copy that text, but it won't let me copy it. That's annoying. I have to do a screenshot. It's the best I can do. Just in case it helps me along the way, like at some point. Okay. Hey Friday, how's this going? Well, if I'm only going in one direction, I could just use resistors. If I'm not doing bi-directional communication, I'm just sniffing the bus, then I probably wouldn't even need to use level shifter ICs. I could just scale it down with resistor dividers and be really cheap about it. But that'd probably actually be more work. In fact, I think I've got some level shifters anyway. It's only like 2 or 3 wire, like I2C and SBI. I don't really have anything for ICs for multiple lines, I don't think. When it comes to mine, anyway. Yeah. I don't know. Anyway, I'll worry about it or not. I'll see. I don't know. I might just say talk to Ian and see how far along he is with his redesign. So he just offered to send me one a while ago. He said, "Oh, I'll send you one." Yeah, I know. Then he said, "Oh, I'm just redesigning something." He's just decided to change the design on it. Hey, B-Blog, how's it going? So I think we'll look at this thing, which I've now put on the floor, so it's a perfectly great place for it. I didn't clean my desk off because I was still sort of contemplating whether or not I finished working on that power supply or not. Decoding the timing, yeah. Well, I mean, I imagine an Arduino will be fast enough to read the bus. Don't know. Anyway. Yeah, so I cleared the desk off from the power supply, which was, I don't know, I'm still not completely finished with it. It's like, I don't like to leave things unfinished, and that's the problem. But I think this is just not worth putting more time into. Runs as fast as the slowest device. Yeah, because it like holds a status line or something, eh? So it turns on a line, then the other device pulls the line or something, and that signals that it's finished reading it, or something like that, I think. So I did read about it a while ago. I've got a book about it somewhere, I think. I read it somewhere. Maybe it was online. I don't remember. Yeah, so I'm pretty sure as we know can handle it, but yeah, I don't know. So oh dear. So let's just jump on the desk over there and do some more work. I've got to try and make a mental decision about this power supply, whether I do just scrap it or if I just try and persevere a little bit more. Don't like to waste stuff, that's the problem. My urge is to continue with it, but logically it doesn't make sense to. Let's go to power supply. Oh, did you see the stream I was doing last night? Well, 9 hours ago, 10 hours ago ish now. Yeah, I don't know if you were here or not. I don't think I saw you here last night. So yeah, it's had a big hole in the power supply, so it's I've fixed the hole, but now the output's not present at all. So, and it's got a blown transistor. GPIB printer emulator. Cool. Is it worth my time to fix it? Hell no. But that's not my channel's about. My channel's about creating content and trying to do things which are a little bit different. Maybe. You know. And I do it to create content for the channel. But yeah. That's always a challenge. Should I set up a vote? Oh. The thing is, my urge is to continue with it, but my mind is saying it's probably knackered, because if it's arced across to that lower supply rail to the discrete circuitry, which it looks like it has, then it's probably blown everything in that section, including the ICs and what have you. So it's like, there's probably no point. Bend the supply and fix the piece of equipment. Okay, so bend the supply and fix the piece of test equipment. Yes, that sounds like a better way. Entirely custom LED display.
No. The only one I'm thinking, the only one that comes to mind if you talk about one of mine is the one which I did for the Datron multimeter where it's smashed. Yeah, indeed. It's just a power supply. It's like it's not worth putting too much into it. It's just fixing a hole in a PCB and putting some new caps in. Not a big deal. But going further, when I think it's probably arced 240 volts or more through to the secondary supply rails of all the control circuitry, it's like probably not worth going any further. Okay, Anna, I'll catch you later on. Maybe I'll still be streaming when you come back, who knows. You know what my streams are like. Okay, let's do something else. So sitting here waffling for ages. There's the desk, which I need to clean off. Of course, I'm handling this power supply like this, and hopefully those capacitors have actually discharged. They may have discharged, they may not. There's a chance they haven't. Do you think I should try that? Because I don't want to take these capacitors back out again if I'm going to scrap the supply. .28 volts and nothing. So this one's got 28 volts on it. So it's not fully discharged yet. I want to take this caps back out, so I'm going to shove that at the back of the desk. And I'll worry about that later. Got these bits of circuit board, these need to go. Don't forget it's all fiberglass, so there'll be glass fibres here, which I definitely want to get rid of because you don't want these in your skin. Probably should have done this before I started the stream. I wasn't sure at the time whether I was going to continue working on the power supply or not, so that's why I didn't bother. I wasn't settled on what I was going to do. Okay. The one thing I don't like about this screwdriver set, just so I can see what I'm doing on here. Pull up my stream so I can see the chat when I'm sitting over here. That's what I normally do. That now I can see the chat. Okay. What I don't like about this is that when these bits are in here, you can't very easily. I was lucky to get that one. Often you can't grab them, get them back out. Just like can't grab the thing. Yeah, the magnet's so strong on it, it's really hard to get it back out. It's just a little thing, you know. It's just like, yeah, it's a super effective magnet. Don't it beat me? Yeah, well, that's right. It's just, you don't always
fix everything, right? It's just part of it. My success rate for fixing things is pretty high. I don't often get things which I can't fix, but it's how far you want to go with it. I mean, yes, I could fix it, but how is it really worth doing it if I have to replace 3/4 of the circuit board? No. But if it's a piece of test gear, that's the kind of length I'll go to, because it's a piece of test gear. Whereas this is just a power supply, so it doesn't really matter. Tumble dryer running in the background? No, it's not, but the NAS is running. You can probably hear the NAS, and it sounds like my stepson is out in the kitchen doing stuff in there, cleaning up. AC is on as well, yeah, but that's really quiet, the AC. I can't even hear it myself, unless it's happening to be blowing across the microphone. It's not. It's only a really slight draft from it though. It's not much. Sun cleaning, amazing. Yeah, exactly. I'm not going to interrupt that. So I think I'll empty out my SD card actually from all the stuff I was recording yesterday. I'm not quite sure how full it is. Nothing like having it run out halfway through a video recording. So I thought I'd better do that, get that out of the way. Yeah, the NAS is still here. I mean, in the previous live stream I said I'm going to move the NAS. Yeah, I haven't moved it yet. Now I've got to find... yeah, I've dragged the whole folder over. I'll sort that out later on. I've got two... Yeah, I think I've got like 2 videos on the card at the moment, basically. I think I have. So I copy it over. Take about a minute. Yeah, I mean, so the NAS is here because it's only a few feet away from the microphone. Probably only 2 feet away from the mic. It's behind it, but it's a convenient spot where I put it at a time. And fortunately, it's a little bit noisy for the streams and recording and what have you. It doesn't really bother me normally during the day. I mean, I can hear it, but it's not enough to bother me. But obviously, when you're listening to audio and something like this, it's a little bit different. I think that copied. I think it did. Okay. Delete that footage. To make sure I copy it over before I delete it off the card. Done that once before, eh? I was kicking myself. I recorded a little video. Luckily, it wasn't a particularly important one at the time. And I recorded a video. I thought I'd copy the footage over. Turns out I hadn't. And then I wiped the card. Lost all the footage. That was frustrating. There's some choice words said that day. Yeah, spinning hard drive because I got there's 14 terabytes or something like that in there. Alright. Let's do it this way. I mean, it could even be that the aircon is blowing slightly across the microphone. I mean, it is a little bit there, but ain't much. There's almost no breeze whatsoever. So I don't know. Boonton, yes. Yeah, because I've got a 4-bay NAS and I've got 3 drives in it, and I think it's 14 terabytes, something like that. It might be 16. I can't remember exactly now, but I need that space for all of my footage, my videos, right? All that has to be stored somewhere, and so it's on that NAS. Plus, all the computers back up to it as well, that sort of stuff too. So it's all it's got a lot on it. I mean, just my computer I use for this stuff, right? This has got about 1.1 terabytes on it. So, yeah, got quite a bit. And it's not even got the videos on it. That's all this other stuff, you know, manuals and bits of software and what have you. Okay. Let's do some video on this. Now, I think I did do something. I think. I'm trying to remember what I did on this before. I've had it sitting here for a couple of months now. I think I just showed it in mailbag and tested it. Let me check my computer, see what I've got there. Yeah, okay, I've done nothing on it so far for a proper video. My folder is empty. I have a folder reserved for it, but it's empty, so I need to basically cover it in full detail. Right, and you may have noticed my bag of HP feet at the back. I purchased some recently from eBay. I thought they were a little bit expensive, but I thought, oh, I'm going to get some extras because I know I'm a bit short on these feet. And the eBay listing pictured 4 feet in the photo, and it said 4 in the listing, and so I bought 2 of them, thinking I was going to get 8 feet. Yeah, I've got 32 feet. What it meant is 4 sets of 4, not 4 feet. So, although it seemed a little bit expensive at the time, turns out I got myself a really good deal. Now the problem is, I now need to buy a whole bunch of HP equipment to put the feet on. You've been 3D printing them. Is that my design you've been printing? There's a couple of designs out there. I actually designed one as well, and that's out there on Thingiverse. But it's like, I'd rather have the proper feet. I mean, my design works. It's okay if you don't spend any money, but yeah, sometimes having the original feet is nice. Got to make sure you've got spares as well. I've got quite a few spares now, and I think I was actually about. I think I only had 4 feet missing. 4, maybe, yeah, actually maybe it's 8 feet. I might have been 8 feet missing off gear. So that's kind of what I needed, just to not have anything without feet on. And yeah, I kind of got carried away, apparently. Unintentionally, it was unintentional. I didn't intentionally want to have spares. So having 32 feet is, yeah. So yeah, I've got a situation now where I'm going to have to buy some more HP test gear so I can put the feet on them, because we can't have these just sitting around without, you know, anything test gear attached to them. You think you made all my test gear foot models at this time? Have you made the shafts for the Fluke test gear? The switch shafts. If you haven't done that yet, you need to buy some old Fluke test gear, so then you can do the switch shafts as well. You done with flexible as well? Yeah, I haven't used any flexible yet. I haven't tried any TPU. I'm going to do it one day. I've got myself a Bamboo Lab printer now. I've actually got 4 3D printers now. Getting ridiculous. But the last one I purchased was a Bamboo Lab A1 with the AMS system, which is the material system on it. You put 4 spools up, and you can do automatic colour changes and that sort of stuff on it, and what have you. And I'm actually amazed at how good that printer is. It's absolutely stunning. Now it's not a cheap printer. It's like 3 or 4 times the price for the 3, but I think it's about 3 times the price. But it just prints. You just literally just tell it to go. It just does it. You don't have to do any tuning. You don't have to do a damn thing. You just say, here's the model. Choose your setup. You know, the settings. Even the default settings work really well. And drop the model in, set it to print it. It's all wireless, and it just goes and prints it. And it's just, I haven't had a single fail print on it yet. Each time it is perfect. Perfect prints every time. It's stunning. So corner bumpers, TPU. Oh yeah. I know the AMS isn't designed for using TPUs, so yeah, if I'm going to use that, I have to use like the standard spool holder kind of arrangement on it. Anyway, we get onto this. They're waffling for another half an hour. Let me see if I can adjust the angle of this aircon vent and see if it maybe changes the. In case it's that was blown across it, I don't know. I know the hard drive is spinning around on the NAS and doing its thing. I'll just tip the vent up a bit higher. See if that changes anything. Bamboo Lab, yeah. I mean, it's been a brilliant printer. I'm actually absolutely stunned by it. It's just so easy to use. It's how a printer should be. You know, you just put your filament in, and it will load it automatically and unload it automatically and that sort of stuff. It just, you know, obviously you get it started into the feed mechanism on the AMS, and the printer will sort itself out. It does its own material changes, does its own purging, it does its own bed leveling. So basically, we set it to print. It'll do. You can select whether or not you want to do it or not, but I suggest you always do. It doesn't take long. You can do automatic bed leveling, so it goes across the bed, does ABL before it even starts, and then also does tuning as well for resonances on the camera system, so it keeps it quiet, relatively quiet. It's not as quiet as my other Ender 3, but it's not bad, and it tunes itself for all those things, mechanical tuning and the bed leveling. It does its own purging and it purges itself out, calibrates itself, and off it goes. And each time it is perfect. It's incredibly good. You know, it's like as user-friendly a printer as you possibly get. I think it's absolutely brilliant. I can't. And I did actually try and get one from Bamboo Labs originally. I was hoping to get a free one, like to review, because other people have got them for review. So I approached them and said, hey, you know, I'm interested in doing a review on one of these things. And unfortunately, I never get a response from them, which is a shame. So I only waited like a week or two. I think 2 weeks I waited, something like that. And yeah, so I bought one anyway. And I'm glad I did. It's, yeah, certainly the best 3D printer I've purchased so far. But then you get what you pay for. You know, the Ender 3 stuff like that, the good entry level printers to get into it a little bit, gives you a bit of understanding and learning about it. But then with this printer, you didn't need any of that. You just put the filament in, did the STLs, and off you go. And they've got the Makerverse or something it's called on there as well. So you can download other people's models and just print out other people's models with no real hassle. It's automatic. It gets all the settings and everything. But I haven't done any of that stuff. All I print is my own stuff. So, you know, their own designs, some STLs maybe. But anyway. Yeah, the Bamboo Lab's incredibly good. Yeah, it does look like a tape over switch, doesn't it? It does look like it. I don't know, maybe it's a little sticker. It could have been a little sticker. There's a little bit of residue here as well, so I don't know. Maybe it's a little cal sticker of some kind. It's possible. Maybe it said don't turn off. Well, that's pretty small for that. So this is the 2520. The other one I've got, I think, was a 2510. I think it was, or 2500. I can't remember what the other one was now. So the one very similar to this. It looks identical, except it's got a different socket on the front, and it's even using the same circuit board. So 8210. Now I've got one of those somewhere. I've done a video on that. Right, here today we have the Boonton 2520 RF calibrator. I showed this in the mailbag previously a while ago now, and I did identify that it is at least working, but it had some issues. So I'm going to just repower it now and just verify it does still work. But the issues it had were subtle, as in unless you actually knew that there were problems, you wouldn't really notice it. So let's turn this off, that on, 230 volts in. I've already changed the voltage selection switch on the back. When I did the sister model to this, I think it's 2510, I think it was, which is very similar, looks exactly the same, so it's got a different socket on the front. And it's a DC calibrator and RF calibrator. They're both two different things. This is for calibrating with the RF sensor heads, and the other unit is for calibrating without the RF sensor head. So the other unit you use to calibrate the actual RF power meter, and this one here you'd use to check the sensor head is correct and the whole system is correct. So, but they're actually very similar units, which is why they look identical. We've got the same display set up. It's even got the same circuit board inside it. So that is quite surprising. Anyway, so this powers up, and it's got an orange display which is not very bright on screen. I'll try and get it. You can kind of see it's there, yeah? You kind of see it's there. But for me, I can see that quite easily. The camera is not quite as responsive on it because of the white balance and things like that, and the ISO levels are not quite there. You know, it's fairly bright, but yeah, it looks worse on camera than it is for me. So I can read that. I'm sitting over here like, you know, a foot and a half away, and I can see it just fine. So although it looks quite bad on camera, it is readable. Now the other unit I worked on before, the display was so bad even I couldn't read it, and I actually did time replacing that display with another one, because it is just a standard 2x40 display. With this has got an EL backlight on it, electroluminescent backlight, and I had to obviously disable all that on the other unit and just replace the display with a standard LCD with an LED backlight, and that was fine. So that video is on my list. If you haven't seen it yet, you can go check that out after this video, of course. So it is working. I've tested it. I've confirmed the outputs are looking really good. I put this onto my spectrum analyzer, and the levels all look good. So I can't complain about it. I've verified it against my spectrum analyzer, and it agrees. So I know the calibrator is actually working well. So this thing goes from minus 70 dBm up to plus 20 dBm, which you can't see on camera, I'm sure. Sure you can't see that. Maybe now you can. Alright, so plus 20 there. Then a minus 70 there. That's the range. And this has got a fixed frequency. It's a 30 megahertz output. So it's a fixed frequency for that. But yeah, it's a really simple unit. If you want to change it to say 69 dB, whatever, you can do that too if you want to. You can do in those steps. But yeah, it's and you can turn the output on and off. Output on, output off. Alright, not too exciting, but it does actually work. So you're probably going, why is it that I'm working on this thing now than in the video? If it works, what is there to fix? Well, there's a few things to fix. I'll pull it apart and I'll show you. The first thing is on the back here, the transformer casing, metal casing. It's got a big dent in it. Right, you might be able to see it better from the side. See that big dent? Now I don't know if it's actually touching the transformer or not. It could be, so I want to fix that. So there's a bit of mechanical work required there. And we go inside it. It's not the right screwdriver, but it's close enough. There's some capacitors, and you can see this one's all bulgy. See, those are nice and flat. This one's bulging. Trying to get it so you can actually see the thing on camera. Maybe you can. See that bulge there? So the caps need replacing. But this circuit board, yeah, I'll do it that way. So the circuit board is the same as in the other unit. Well, I think it's a slightly later revision. It's almost identical. When I first opened this thing up, I thought that is exactly the same board. In fact, if you look up here, 25102, 2510-2. So I think it's revision number 2 of the 2510 board. Now I don't remember what the revision was on the 2510 version I did before. Might have to go back and look at that. But it's very slightly different over here. This power supply section is very slightly different. But the rest of it looks identical, the way it's set up and everything. So you've got some dip switches at the front here. Just make a note of those in case you accidentally hit them. So try and get a view there. There we go, you can see them side on there. So the only one which is turned on, I think, is, well, the one which is open. The only one which is open is switch number 7. The others are closed. Anyway, so it's definitely got a slightly different setup. The other unit I looked at had a connector on here that had a plug in there as well, the 2510. So it's a slightly different configuration. I don't know exactly why it is, but it is. So anyway, we need to pull this board out, recap it. Whilst the board is out, then I can get this transformer out, or at least dismantle it, try and get that back cover off and take the dent back out of that whilst the board is out. So that's the plan. Check the chat. I missed quite a bit. Several thousand miles away, you can't see the display, yeah. 3D printers that cost 60,000 K, wow. Laser cutter cut 20-foot container walls, that's impressive. Yeah, I don't know. It's calibrating the calibrator as well, yes, I think, isn't it? Socketed IC is nice. Now, it does have an EEPROM in here, so I'm actually tempted to pull that EEPROM and back it up. I'm tempted to do that too. Actually, can I? No, I can't do it right now. I will have to do it though. I do like to back up EEPROMs if I see them. My wife's computer is currently with my wife, who's currently in Australia, so I can't actually do that because the stuff I use works on her computer, not on my Mac. Alright, yeah, let's strap them together. It's probably just to reinforce them so they don't get knocked around, make them more stable. Anyway, I need to get this side cover off, get the right screwdriver this time, which is this one. So to get this out, we need to take off the strap which holds the heat sinks on the transformer. You have to remove the heatsink which is attached to the side chassis, which is mounted onto the regulator ICs, which is through here. That screw there. Well, in there. It will be behind there. We'll get this panel off as well. There's the screws. So we need to undo those so we can get the heatsink off. Now when I did the other unit, the 2510, that's quite fit. There was no heatsink compound behind here. I actually added heatsink compound just to help the regulators run a little bit cooler. I mean, in fact, there was nothing near from factory. It means it's probably fine. I mean, it's been like this for how many decades now? But there's no harm in helping it a little bit. So that's those out. Okay, so those regulators will remove. Yep. So we've got to get the board out, undo the screws, and I'll start pulling plugs out. Or should I pull plugs out and undo the screws? Let's pull plugs out and undo the screws. So a lot of these are obvious where they go. You can't get it wrong. Famous last words, isn't it? There's two here. The orange and black is towards the front. Yeah, you've got the brown, and it also goes that way, so wires come out the right hand side. Okay, so the orange and black is the front one, the brown and white is the rear one. Okay, one of those will be 5 volts output, and the other one will be the high voltage output, or something. I can't remember exactly what it was now. They're both 5 volts outputs. Actually, they might both be 5 volt outputs. I'm not quite sure. Could be the same thing, but best not risk it. Keep them the same way. And you've got this plug that goes to J5. Unplug that one. You've got one here that goes to J9. Wires go to the left hand side. Then we've got the GPIB connector. And on there. Now we get to all the screws. Get the thing out. I don't know if I can get these out of the magnet. I'm not sure if I can. Yes, I can. That works. There's no washer. Sometimes there's a washer. That one has a washer on it. Style washer. The magnet just helps the screw to stick to the screwdriver. So when you've got ones which are in awkward places, then they come out with it. Just helpful. So if you get a chance, get yourself one of these magnets. Just a little one, doesn't that take that much? Just makes the job easier to do. If I'm trying to get into with tweezers. Can also make it easier to put them back in again as well. Obviously not all screws are magnetic, so you know that could be a hindrance. Depends on what screws there are. And that's stuck to the stuck to the casing of the transformer instead. Here we go. Now is that all the screws? Must be because the board's moving. Right. When you lift it out, be careful not to snag on the wires of other stuff. Okay. Pulled out. And the transformer is going to be awkward because I've got to get it from both sides. But we'll do the circuit board first, then we'll worry about the transformer. So, now the board's out, I'm going to recap the entire thing. Every capacitor is going to get replaced. Now, the tricky thing is to make sure you put the capacitors in the right round. Even I get that wrong. Like, I did one yesterday. Actually, I'm going to slide that off. I better reuse it. And I accidentally put some big caps in backwards on a live stream, so that was great. They got a bit warm. Didn't blow up. Yeah, you know, these ones here. This power supply is knackered anyway. I was hoping to fix it, but yeah, it's a shame. So we've got 3 caps down here, 2 smaller ones here, another one there, and also these 3 big ones here. I think that's the extent of it. So 1, 2, 3, 6, 9 caps. Yep. So let's get the equipment warming up. I will need this. Unfortunately, it's a little bit noisy, but that's what we need. And I need to look at. I think I'll do the small ones first, and I'll come back and do the big ones after, because I won't forget those, but I might forget these. What values do we need? 10 microfarad 25 volt, 10 microfarad 25 volt, 10 25 volt. So these are bigger. So these three are the same, and the ones up here with the regulators are harder to see. It's a 100 microfarad 25 volt at least for this one. I might have to look at these ones as I take them out. So we'll get the small ones out anyway. 10 microfarads 25 volts. Let's get some of these. Let's dig down. Problem with my eyesight getting worse, it's making this sort of stuff harder to do. That's a 35, that's good. I think that's bigger. And 35. Different brand name. I want to keep them all the same. Just for, you know, I'm just fussy like that. Want them all to match. So when I find I don't have a set and match, which is matching set, that'd be annoying. 35, there we go. There's a matching set. It doesn't really matter usually, but I just like to keep them all exactly the same if I can. If I'm replacing caps, I try and keep them as a set, so they're all exactly the same caps for the whole lot. Sometimes it matters, usually it doesn't. But I like to try and play it safe. Jet. Good idea to back up. Yeah, I definitely will. I will do it later. I mean, it's only 2 screws to get the cover off, so it's not like a big deal. So I can easily pop it out later on. So this thing here, it says 509 AD on it. So I'll have to sort that out later on. Same thing with transistors. I have never seen transistors strapped together unless they're like a matched set, though they're trying to thermally tie them together. I've seen them like glued together, things like that. I've done that, seen that done before. Where they're trying to keep them so they react in the same way together. It's like a matched pair kind of arrangement. That's what they're trying to do. Yep, you guys covered it. That's all right. I saw the question there, but asking what we're doing. Digital seeing aids. Glasses and analogs said so last decade. Yeah, definitely digital glasses. Is it an AD 580 reality reference? I mean, over here. It is definitely an AD device. Let's get closer. I think I almost said it then. 581. AD 581 JH. There you go. 995. So just over here, it's an AD 581 JH. Try and get your focus again. Wobbling everywhere. There you go. From 1995. These other chips are 95 as well, so it gives you an idea. So this thing is basically 30 years old. So if you got like a bootstrap circuit on a circuit, so sometimes the bootstraps which are used in op amps to help boost the rails, and they're like a negative feedback or positive feedback system, and you got a positive negative side, and if you've got different capacitors, you might find you got different responses on each side, so it could cause skewing of the op amp outputs because the supply rails could be varying slightly. So if you keep them the same, at least then they're matching. I just like to keep them matched if I can. Maybe it's more of a fussiness thing than anything else, but at least if they're the same, you know they're going to be matching and behaving the same way as much as you can predict anyway. You know, always going to get variation from manufacturers anyway, but at least you get the best chance of getting them to be behaving. Let's move this out of the way, it's just annoying me. Alright. So, we'll put these capacitors in the correct way around, won't we? Right. We're definitely going to put these in the right way around. You definitely do it the right way around. So I'll start taking these caps out. Now in this case the capacitor, it's on this clean, the left side is negative. So I'll put your fresh solder on first. In fact I'll just do fresh solder on all the caps first, then I'll come back and suck them all out. One over here, the right hand side is negative. I'm telling you so you can tell me when I get it wrong. Right, so you're supposed to be there as my guide to say, oh, you got that wrong. And the other one up the top here, the one closest to me is negative. Fresh solder just makes them easy to get out. Okay. One. Now I'm going to do the sensible thing here and put them in as I take them out. Because otherwise I could lose track of where I'm at and accidentally put one in backwards, and that's always a bad thing. Don't ask me how I know. It could be anything. Right, and this one here, negative is to the right hand side. Probably a bit close enough. You can put it out slightly. And then this one here, negatives to the left hand side. This tool is one of the best things you can get if you do electronics repair stuff. It just makes refurbishing things so much easier. It just makes it easy. Solder those back in. I'm not going to use flux. I don't tend to use flux unless I actually need to. I'll just try soldering and assess how it's going and base it from that. And I should really turn this extractor on, which is why I put the hood here. That's a third of the way there. You get the idea. I won't record the rest. Okay, thanks, Paul. Catch you later. Right, let's pull these ones out. So two of them have got the negative towards the heatsink, one's the other way, just to make it awkward. It's obviously a, well, they've all got the same circuit design. Obviously one's a NPN. Got two positive regulators, one negative regulator. I'm guessing that's what that is. Just fell out. Yeah, so 100 microfarad, 25 volt. Next one. The same again. These are power supplies, so matching them doesn't matter. But it would be for aesthetics. Let's have a look. It's a 35 volt, 25 volt. I'd rather keep 25s. 25. I'll assume the last one's the same, eh? 25. Do that. And these actually have markings on the board as well. That's nice. How novel. And they're even correct. That's even more novel. Just because there's a marking on a PCB doesn't mean it's correct. Sometimes they're not. So I've been meaning to get myself a proper extractor like this for a long time, but they're not cheap. So I finally got around to buying one, but now I've got to try and get in the habit of actually using it. Now I did add to that one which I built, which was actually maybe slightly more convenient. It was quieter, but not as effective. Yeah, it's the same, 100 microfarad. I'll check the chat again in a second. My biggest concern is that this extractor will be too noisy when I'm trying to do live streams. You know, because obviously they're not quiet. So that's one of the things I was really worried about. So this is actually set to its lowest setting. It can't go any lower, because otherwise it gets a lot noisier. Right, chat. Turn it off again for a second. Let's have a look. Beat lodge, yeah, not quick enough, mate. Yes, they are indeed using a square pad round pad. I mean, as was the power supply last night. However, for some reason I interpreted the square pad as the negative, not as the positive. And I don't know why I was thinking that. The square pad usually is the positive, but not always. It usually is. So now we've got these big caps here to do. Let's just record this bit. So that's our small caps all done now. Now I'm going to move on to doing these big caps. Again, I'm not about recording that. You get the idea from what you saw me do before. Recapping is not exactly exciting. The exciting bit is when you power it back up again and find out you put the caps in backwards. Yeah. It's only 85-degree rated too. So it's got those small caps directly on the outputs, and then it's got these larger ones as well. So it's like a two-stage of filtering. So it's got the main smoothing caps, then, well, the main smoothing caps here, then probably some kind of noise filtering. I guess maybe it's to help the regulators out. I don't know. Having two sides of caps is also good because it gives you different frequency responses, so you filter different parts of the noise. So it's probably based on that, I suppose. Right. Take the bulgy one out first. Uh, 4,700, 16 volt. .25 volt. We've got a 16. I think these are all 25s. Yeah, these are all 25s, all the same. This one isn't using square pads. But it's marked on the board. So, yay. Negative to left, this is a 2200, 35 volt. And what's the other one? It's the same. Again, we'll try and get to the match pairs thing. Come on, we'll try and get the cats back in the drawer now. We'll draw back into the cabinet. There we go. Right. So that one goes that way around. Double checking this. Yes, it was how it was. Oh, no, I've destroyed it because I dropped it on the floor. Never to be seen again. That's a cool video on this bit, I suppose. Bit of closure on capacitor side of things. It's now to soldering in these big caps. So we had two 2200 35 volt caps, which these two ones which were not bulging, and then we've also got a 1000 microfarad, was it? 16 volt? 4700 microfarad, 16 volt was the one which is bulging. So that's the one which I've also done. So that's all the caps done. So once I've done that, I'll clean the board up, clean all the flux off. Need to do that, and then I've got to try and do the transformer and see if I can get that to not be bulged, not be dented anymore. It's not something I had to do before, so it's a bit of a new experience for me as well. I've never had to take a transformer apart like that, so we'll see. It could be interesting. I could completely screw it up. It could be easy. I don't know. Never done it. We'll find out shortly. Ian, question for you. That GPIB thing you had, that sniffing tool, you said you were doing a revised version of it. How far through are you with that? Because I'd like to sniff my GPIB bus. That sounds wrong, doesn't it? And the tool I've got isn't wonderful. I'm hoping that the one that you've got would be better, and I'm hoping that it's at a point where you can actually sell me one. That's right, I said sell me one, not just give me one, sell me one. I know you keep giving me things. Don't mind paying my way. I glanced at your email too, Ian, about your assistance for that issue I was having with the communication for the GPIB. So I obviously haven't had a chance to do anything with it yet, but I've seen it there, so thanks for that. Maybe I'll play it again later on today and see what we can get. Switching levels aren't quite accurate enough. Oh, okay. Well, it's not if it's not ready, that's fine. I'm just thinking if it's basically done, then I would like one because it could be helpful right now. Yeah, I'm not too worried about the capacitor voltage. I mean, generally it's pretty safe. It's only power supply smoothing. These ones aren't critical, not really. And it's after linear regulators, right? So you've got linear regulators coming in. So it's really just for storage. There won't be much in the way of noise coming out because they are linear. So, or are they going into the regulators? Ooh, actually, I should look at that. AC comes in there, goes out there. No, they're going into the regulators, I think. Yeah, the bulk regulators going into the regulators, not out. Yeah, the bulk capacitors going into the regulators. So, as you'd expect, so you've got a bridge here. AC comes in, bridge is here. Zoom out slightly, you can see what I'm talking about. Maybe get the sign off. So AC comes in here, the bridge is there. Obviously, then you've got the bulk caps coming in from the bridge. So that's then doing the main smoothing, and then it comes up to the regulators up here, which have then only got these really small caps on the outputs because they don't need much capacitance on the outputs. These things generally, and obviously then you've got localized capacitors where required. So that's fine. Okay, no worries. Yeah, thanks for that. Right. I think I can put that away now, and I think I can put that away. Turn those off. Get rid of some of the noise. I think I'm done with the soldering. Let's put this thing back into the casing. Oh no, I can't do that yet because I need to fix the transformer. I think it'll be in the way. Let's just stick it over here. Let's balance everything precariously. Actually, let's test these caps. Let's see what these are. And I'm going to use tweezers. Now I've got this one. I've also got the Shannon tweezer up here as well, which is more accurate generally. I mean, I think it's slightly better. I mean, these are much more expensive. These are relatively cheap. These are really expensive to get now. These are really good. It's amazing the technology you can get now for the price. These have got much better precision on these. If you're trying to do like small SMD parts, these are much more precise. These are really rigid, like for the twisting. They don't twist as much. These are really good. So I mean, basically, if you can stretch out and get one of these Shannon tweezers, do that. But these are good for most general things, you know. So if I was doing precise SMD stuff, then I'd be using these because they're much better for the alignment. So let's do this and try and get it so you'll be able to see what I'm doing, hopefully. Right. So let's actually check these caps that I pulled out and see what kind of readings and stuff we get off them. So let's get closer. So this one here is the, what is it? Hold on, I've lost it now. 2235 volt, one of them. This one, which is on, it's 1K, let's change it to 100 hertz, make more sense. So there you go, 227 or 237. So it's fine. ESR 60 milliohms. So that's actually still a good cap. But I like to replace these things anyway. This one here, which is the same cap. This one's looking suspicious on the bottom, but still measuring fine. 2.4 at 51 milliohms. So that's also still good. I'm just sort of suspicious about this. See this stuff here? And it's also looking slightly bulgy on the bottom. Could be starting to go. This one here is bulging on the top. That's a 4700. What do we get? It's really slightly low, and the ESR is only 46 milliohms. Also, still measures good, but it obviously isn't because it's bulging. So let's do this one, which is a 100 microfarad, 25 volt, measuring okay, 1.2 ohms. That seems normal. Same again. And the biggest thing, if you've got lots of caps which are the same, if you see ones which have got variations, that's when you have to worry about it really. Really slightly low, and the resistance is still about the same as well. But that's basically okay. I mean, none of these caps seemed horrendous. I mean, the actual unit worked fine. There was no signs of issues with the power supplies, but it's still just a good thing to do. So this is a 10 microfarads measuring 11, so it's 10% up, 8.8 ohms. Probably okay, maybe a little bit on high side. This one's 12, so this one's definitely worse. Right, this one's on the way out. And this one's 5. Okay, so this one's better. So the 8 is also bad. So that's 2 of those small caps are definitely going. But that's why I measure at 100 hertz, because it actually makes things more obvious. So yeah, I mean, recapping was needed. We had one cap which is obviously bad, and that was, although it's still measured fine, it's still working, it's obviously on the way out. And 2 of these small caps are definitely dead as well, even though they looked fine. So, but this is why I just do this. I mean, I could have just replaced the obviously bad cap and moved on with my day, but the small cap's only been so obvious. So, you know. But this is what I do. I mean, I recap because it's an old piece of gear. It's 30 years old. I mean, the caps could even be okay this week and not okay in a month's time. You know, they could suddenly start leaking and that sort of stuff. But then the really well-made caps from many years ago, they can still be perfectly good for several more years. But you don't know, it's a gamble. So, you know, I'm very much a case of, if it's not a big deal, replace them all, have done with it. And at least now you've got caps which are probably fine. I mean, they may not last 30 years like the originals did, but you probably get 15 years out of them, and that's probably long enough. Okay. Just checking the chat now. Really get those tweezers in your ears to clean them out, yeah. Power supply from. Just should have discharged them before testing. Actually, that's a good point. I do tend to forget to do that. Yeah. So. I mean, if it's like a piece of gear which I was maybe intending on selling for profit, sort of thing, then maybe I'd just only replace the caps which do test bad in order to minimise the outlay. But if it's something I'm going to keep, then I want to make sure that when I go to use that piece of gear, it may not be for 5 years before I go and get it back out again, or you know, even longer. And I want it to be able to pull it out, power it up, and have it work, and not worry about whether the caps have failed in that time. I mean, there's no guarantee the new caps won't do that, but the chances are much better than these old caps which have been in there for a long time already and obviously aging. So, right, let's clean this mess up and we'll start looking at that power supply with the transformer dent. Let's get some room. Don't think I'll be using that. But no, maybe I could. They do touch together. Let me see if I can get this on. Hey, look at that, it's good as new. I could just leave it loose like that, eh? So it's not too tight on them. There you go, done. That'll do. Right. So what I've got to do on here, I'll just explain it once I start recording again. I'll get the bottom cover off as well. Zoom out a little bit, I think. I think all I've got to do is no, that's not quite that easy. Back panel also needs straining because it's also bent. How much of this do I have to take apart? It's also got a board under here. It's all the RF stuff in here. Just trying to evaluate how far I can go with getting this thing apart. So I'd like to take the back panel off because the back panel is also bent. Now I've got all the casing off, I can actually see how bent that is. So, yeah. Right. There's bloody reflections on this thing, terrible. So I've got the bottom cover off as well now. So there it is there. That's all the RF stuff, so we're going to leave that alone. I'm just trying to assess how much there is to take off the rear panel here to allow me to take it off, because if I can get the panel off, I'm going to strip it off on the bench. I think there's like one wire here which might be an issue. It's like maybe it's a coax which goes up somewhere, I'm not quite sure. Most of it's actually plug-in. Like you've got the power, this one here, that unplugs, everything else seems to be basically unplugged. So I'm hoping I can just take the rear panel off and then I can strip it down and straighten the back panel as well, because the back panel is also very bent, as it turns out. You can see it there now. Now I've got these other panels off. You can see how bent that is. This one is straightening too. So maybe that way you can see it too. It's dented in. So I like to straighten the whole lot out, not just the transformer. So I'm going to try and let's take it apart and see how far we can get with it. See what we come across. Thankfully they use the same screws for everything, so it's really easy to not mix them up. I think the one I'm really worried about is this bit. I'm not quite sure if that goes in, which I might have to then desolder. I'm not quite sure. That's the controlled output signal, whatever that is. Right. It's moving, but not coming. Is it just... what's holding that? What's holding that? Is it that screw there? Might be that screw there. Yeah, it's that screw there. There we go. Okay, that control out was also plugged in. That's good. So I've got one wire got unplugged, which is coming through this little snatch thing there. Unplug that, and then we can work on the rear panel by itself. That's great. I love this design. Love designs like this. Yes, I do when I can get the things apart. Come on. It's very tight. There we go. Lovely. This makes things easier. So now all I've got to do is unmount the transformer, which is something I need to do anyway. Mind you, I've got wires going in there. I've got to be careful with that part. I think I need to take this cover off here too and have a look and see what's inside here. Those are wired directly on, so I have to be careful with this. So this is going to be a little bit trickier, but not too bad. Just got to be careful. Put that back on again. That screw will go in somewhere. Do this? Yep. Right. So I need a nut driver to get under these. Oh, look at that. First one straight away. How's that? Look at this. Check and chat out. Right. I think the whole one's turning there. It is. course it's going to be a little bit awkward. So some little washers on here. Try to lose those. I'll get them off. The main concern is pulling on the wires when I loosen the transformer off. So we get these off as well, because those bolts got to come out. Right. So that's all the nuts off and the washers are off. So now, in theory, I should be able to get these bolts out from this side. They may just unscrew out. Now, when I do this, I've got to be careful about the wires on the transformer, because obviously they're a bit short on the input side, on the primary side, and I've got to be careful not to like drop the transformer and have it yank on the wires or anything like that. So, yeah, we'll see. It should be straightforward. I mean, I think I've just got to basically get these bolts out, take this cover off and straighten it out, and whilst it's out then I've got to try and do the back panel, which could be a little noisy, but the back panel is aluminium, so it should be pretty easy to straighten that back out. That shouldn't be hard at all. This transformer cover is obviously steel, so that's going to be a bit tougher to deal with. Right, I'll get these out and I'll come back. $500, yeah, those tweezers are good. I've done a review on them, so I don't know if you've seen the review or not. The accuracy is actually really good. So they compare favourably against other more expensive tweezers. Like I've got the Shannon tweezer, which I showed just like a few minutes ago. That is a much more expensive tweezer. The state of that. Thread lock. At least I put thread lock on. And so it compares favourably with that. It actually does quite a good job. Considering the price, they're extremely good. You know, if you don't want to fork out a lot of money for a really expensive high-end tweezer, then yeah, I mean it's like $30. I think they weren't expensive. So you know, get them. They're extremely useful. Obviously, I've got proper LCR meters and stuff here. I've got a few different ones, and so I'll compare them against those, and they're fine. You know, I think they're not perfect in everything, all aspects, but for hobbyist use, absolutely fine. You know, if the capacitor's bad, it will tell you. That's the main thing. Obviously, the capacitor testing is what they mainly use for. So that's the thing to consider mostly. Right, now I'm going to record some more video once that bike's finished going past. Careful about the viewers of nut allergy. Oh. Right, so I've got those bolts out now. Let's lift this out. And like I said, I've got those. Oh, I'll take this cover back off again. That's silly putting that back on, I think. Gives us the freedom to move things around a bit more. Okay, there we go. Right. So, I've got to get this cover off. There we go. That was easy. And so it could have been rubbing on this transformer just here. It doesn't look damaged. I think it wasn't touching, but I still want to straighten it out. And then I've also got to do the back panel, which is aluminium, so it should be easy to straighten back up. Can't really get some hammers. Hammers, hammers, hammers. There you go, got my hammer. Do you think this will do it? Okay, maybe not that hammer. Maybe I'll go to one of these hammers instead. Right. So let's try and do it this way. This is going to be noisy. Sorry, it's a record video as well. So I've got these hammers here. I'm just going to use this one to try and get it initially straightened a little bit. Can be a bit awkward trying to do these sorts of things sometimes. That's already popped out a little bit. Alright, and in fact it wasn't actually touching the transformer. This is more of a cosmetic thing than anything else. So I'm going to try and get that to be kind of right. I mean, unfortunately it's not. I'm trying to hammer it a bit, which is bent, which isn't helping. Obviously I've got it flatter, but I need to kind of pull it out. So it's going to be a little bit awkward to do. But yeah, I don't know. It's one of these things, isn't it? Yeah, I probably need to support it on this edge here so I can pop that out to where it's supposed to be. I have to figure out how I'm going to do that. There's always ways. Sometimes it's awkward. Okay, I found a way, and it's awkward and it's off camera, so I'm not going to record it. And it's noisy anyway. So. It's kind of working. It's quite soft actually. I think it might be aluminium as well. I think it was less ugly when it was bent actually. Kind of awkward. Right. Now repair plastic traces, repair traces on flex PCBs. Yeah, just very carefully. I've done it a couple of times. Not easy job to do. Definitely not an easy thing to do. Well, it's getting there, but it's not great. It's a shame the paint is damaged on it. But, Work? Yeah, maybe. Years ago, a guy at work, he dropped a mould, and it basically on the machines. I'll explain this a bit because some of you won't have a clue. Injection moulding, right? And there's a big mould area. You've got the mould, could weigh tens of kilos. For a small mould, could weigh several tons or dozens of tons in some cases. And a guy at work was taking a tool out of a machine, and he forgot to hook the gantry up to it to actually lift the tool out, and he removed all the clamps to hold the tool in. The tool dropped, bang, straight down, and on the tray, the bottom in the machine, there's a tray which came down, which the products normally drop down, and it got a bit munted. So I spent a little while panel beating that tray to get it basically flat again. Because we couldn't really do anything with it until we fixed that tray, so we could put the tool back in again, or tool in, and get the machine started back up. So that guy had a really bad week. I think he dropped 2 tools that week. I don't know what was in his mind. It normally wasn't an issue, but he just did. He was having a bad week. Don't know why. He hasn't done it again since. So I don't know. He just had I don't know. Hadn't done it before, hadn't done it after. I don't know what was going on there. I think that's good enough for that piece. Right. So yeah, as beaten out, it's basically the right shape now. It's good enough. It's certainly better than being dented inwards. It's not perfect, but to be honest, it's good enough. It's not in anymore. Now to the panel, which one should be a little bit straightforward. I should be able to literally stick on this like this and just use a soft hammer and pop that back out. It should not take much at all. It's getting there. It's not there yet, but it's getting there. Gonna need a respray. Yeah, I'm not gonna bother with that. Mrs. out of town, yeah. She's been it before when I'm doing it, and she has complained about the noise. Well, more curious about what I was banging or anything else. Conductive pen. I mean, conductive pen is not wonderful. They're not actually that good. They still have a resistance, and they do tend to like peel back off again. The best thing is to use some really fine wire. Solder some really fine wires on. Just get some wire and take some strands out of it, and you may have to look for a couple of different wires to find ones you've got the strands which are thinnest, which can do the job, and then just literally just get those all prepared and lay them on top, and just tap it with the soldering iron, and it should just adhere to the original traces. Yeah, but that's the way to do it. It's tedious. You need a microscope. Yeah, you can do it, but you don't linger on the soldering iron. Just get the wire perfect so the wire's ready to go, and just brush it across it, because the heat will transfer really quickly through the wire and into the trace. So you can do it, but you do it quickly. All right. Scuff out my aluminium now. That's annoying. It's not too bad though. It's just about there. It's going to be a bit awkward trying to hold everything. Right, I think that is done. What do you reckon? Close enough? Give it a tweak like this. Just about there. It's not perfect, just about. That bit there needs to come down and be pushed in that way, a bit like that, I think. Yeah, I think I'm being fussy now, mate. What do you reckon? Yeah, okay. So that's all panel beat now. That's basically flat. It's flat enough. It's certainly better than it was. So we can put it all back together again now. Magnet wire, yeah. I mean, you get depends how many wires you've got to do across the flex. If you've got to do a bunch of them side by side, then you probably do want to use an enamelled wire, such as magnet wire. But you may not need to do that. So if it's just one or two strands which are not going to be close together, you could use standard wire, just a strand from that, which would be easier to solder. And then that'll make your job a little bit easier. Try and do it that way, right? But if you can use standard wire, it will be easier to do. But sometimes you have to use the enamel stuff, which just makes it a little bit trickier. And use solder mask afterwards. Get some little solder mask syringes. I'll show you one in a second. Yeah, these kinds of things. Little syringe of solder mask, UV solder mask. Get some of that. Stick it on it afterwards and treat it with UV to cure it, and that will hold it all together. Enamelled wire is used in transformers, but no one calls it enamelled transformer wire. Yeah, it's true. Do you think I should put some thread lock on these? I probably should, shouldn't I? Had thread lock on them originally. Should probably put some new thread lock on, just to make sure the vibration from the transformer doesn't cause them to come loose. I should probably do that. I'll do those two, then I'll undo those ones again, put it on. Wait, I'm not going to paint it. No, I'm not going to paint it. It's fine. I'm not going to paint it. You focus, you bastard. There we go. Come on, down there. Right. So I'm going to use some of this thread lock on these bolts as well, just like the original did. The factory had some thread lock on there of some kind, so I'm going to do the same as well, just to make sure that they don't vibrate loose, because it is a transformer, and transformers do vibrate very slightly. So I'm just going to put that on there and make sure that these don't come loose by themselves, because you don't really want that happening. Last thing you want is one of these things floating around inside the unit. Use some nail polish. I have used nail polish before. For various things. Even used it on circuit boards. Looks fine. You know, in a pinch, this is what you got. It'll work. Don't have to worry about it too much. Oh no, I've lost this bloody nut. Click, as the saying goes. Come on, I've lost this. There it is. Was a fairly easy repair, this one. I assume, of course, it still works. I have to try it and, you know, power it up again afterwards, make sure it does actually still power up. I haven't done something horrendously wrong and destroyed something else. They said they finished editing a video, having a beer. Great. Is that the display one you were saying you're going to do? Fixer. Hey, I'm fixing a Boonton 2520 RF calibrator. So I had some rear damage where it's been dropped, so I just straightened all this up again, got that nice again, and so it's not bent anymore. And I've also recapped it, which is evidenced by the capacitors. I don't know why there's trouble saying that word, I don't know why. Got to put the cover back on again, yeah? Oh, that fuse holder's loose. Just noticed the fuse holder's loose as well, so we can tighten it up while we're in there. Hopefully it's not like a cracked nut or something, that can happen. Or stripped threads. No, it is tightening, so let's get into some pliers. Set a nut there. Now this is a bit awkward to get into, especially I'm trying to do a video about it as well. There you go. Nipped up, that'll do. Won't take much. Should have repainted the back cover. Yeah. Don't make me regret that now. Trying to figure out which the best way is between there or around the top. I think around the top is better actually. I've all disturbed it all now, haven't I? outside like that. This has dropped straight back on again, but now I've disturbed everything, haven't I? There's a screw hole there somewhere. There we go. It's in. Ish. Okay. Let's put that bit back together. Really should have repainted it. Yeah, you're going to keep going on about that now, aren't you? Yes, I probably should have repainted it, but the reality is I'm a bit lazy and I tend to avoid doing things which I don't really have to do. And this comes under that. Quite clearly comes under that. Underneath that little, there's a little holder there. Try and get it back under there actually before I put it in place. It's a little bit awkward, isn't it? Yeah. Right. I think all the wires are going to the right places. Okay. It's got one of these Boontons, but it's got a really nice back cover. Yeah, thanks for that, Ian. Yeah, that's just great. What are you trying to say? Sure, there's a message there somewhere. I'm not quite sure I'm getting it. You guys aren't being clear enough about this. Thing is, if I painted it, I would have had to put it to one side, and I couldn't put it back together again until tomorrow. And I would have been left with this thing in pieces. And that's annoying. I don't like leaving things in pieces. And then I couldn't actually finalise the repair today during the live stream. So there's all these reasons why not painting it is a much better idea. Well, the denting was more of a case of making sure I wasn't touching the transformer inside. That is the main thing I was worried about. It wasn't so much for aesthetics. Obviously aesthetics does play a part, but it's not the reason for it. Okay. So that's the rear panel refitted. Now we're going to put the circuit board back in again. And I'm also going to put some thermal compound on this, on these regulators, just to help them to dissipate heat into the chassis. But like I said before, it didn't have them on there originally. It's probably fine, but why not do it? It's probably a good idea. Get an exact paint match. Yeah, no, it'd be blank. It'd be whatever colour I have on hand at the time. That's the colour it will be. So, yeah, if it was me doing it, it's like, no, I don't match paint, not like that. I just, no, I mean, for a start, I'm in the middle of nowhere, right? I'm nowhere near anywhere which does paint. The closest place that will sell paint is probably 45 minutes away. So, yeah, not happening. Of course, the wires are going underneath it. Of course, they have. So before I screw down the board, we're going to screw on that, and I should probably talk about that in the video. So I've just placed the board back in again, made sure all the wires are out, at least I think they all are. That's always a pain when you put something together and find there's a wire trapped underneath. So the first thing I normally do actually is plug all the wires in, but in this case some of them will be in the way, so I'm not going to do that. I'll just sort of visually go around and make sure that they look like they're okay. Now, you could screw the board in, but then you've got the issue with potentially got the regulators being stressed, trying to be pulled towards the chassis. So I'm going to just mount that on first, and then do the screws on the PCB. That way it should have no stress being applied to the regulators, because they can crack. The actual legs can break off, or the circuit board traces can break, the actual pads can break and that sort of stuff. I've seen that before in regulators because of the thermal effects as well, because it's thermally cycled. So I've seen that before where the track is actually, like, the solder pads are broken by the regulator legs and that sort of stuff, and they've been pulled, and I've gone to resolder it and things actually shifted because it's been soldered and then applied, and then that meant that it was all being stressed, and that's what made it crack. So anyway, that's that one. And because those are countersunk screws, it can only really go one place anyway, and then that guides the rest of it to where it's going to be. So now we should put this back in again. Now, where's my magnet gone? Because this makes this job a lot easier. Stick that on there like that. Now, I'm just going to put them in, not tighten them up yet. Go around afterwards and tighten them up. Oh, I'll nudge that one off. You don't tighten them straight away, otherwise what can happen is you'll get ones which are then not lined up properly and end up going a bit crooked and things like that. And the board is going to be mostly aligned because of the fact we did the regulators first, but you can still get some slight offsets. There is still a bit of play in things, it will still move slightly. So, anyway. Oh, drop that one. Anyway, I'll come back once I'm done. You get the idea. Powder coating. Well, you guys really are getting serious about this. I might wonder if I just put one of the case screws in here. Oh, they're exactly the same. No, that's slightly bigger. 2, 3. That's right. I'm thinking I might have used a screw somewhere, but shouldn't be where it's supposed to be. I'm not sure. Three screws. Well, I've got 3 screws. What am I missing? Have I forgotten something? So, done. So going clockwise to make sure I've missed any. Don't think I have. It's always a good idea to do it. Okay. So I've got 3 screws here. Why is there 3? Oh, that's right, it's one more on the back panel. That makes sense. One more there. Now I can count. Now I'm happy. Sketch up the jet. So I think basically what happened is someone must have dropped this thing at some point in its history. You know, it's like, because that sticks out the most out of the whole thing. That sticks out. So there's a good chance it got dropped on its back end, and that's what dented it, or someone dropped it. Honest grateful was nothing like broken anywhere else. So I was plugging all these plugs back in again now. These ones are the ones you've got to be careful of. These are very easy to bend the pins on if you're not careful. Now, which one was which? I think that one or that one. Which was the one which is closer? Oh. Yes, that was there. The orange one was here. Okay, so that's in. Dip switches are still in the same place. That's in, that's in, that's all in, that's on, that's all done. Right, let's power it up and see if it still works, eh? Or have I destroyed it? Well, let's boot it up. There you go. Change the levels, that still works. So it's probably good. Do you think I should actually track the output and I should check the output, shouldn't I? Just to prove it does still work. Let's do that. The screen's still there, you just can't see very well. It's just because it's an electroluminescent display, it's not very obvious to see. It's just a bit dim, like some people, maybe me sometimes. Just putting the handle back on again. Trying to put the handle back on again. There we go. So what I'll do is I'll turn on my spectrum analyzer and check the outputs on that. That's the top cover, not the bottom cover. Turn it on, it'll take a little while to boot up. So at a later date I will pull this thing apart again and back up a copy of the EPROMs, or EPROM. What did I do that on? There was someone asked me for help with one once. It might have been the 2520, or was it one of the other Boontons? I can't remember exactly what it was now. AM/FM modulation meter, one of those. Because I've got a couple of those as well. I've only got one now. I think I sold one. The EPROM and that had gone bad for someone, and I managed to burn a copy off for them and save their unit, which is quite good. Let's just tie up a little bit. And I'll get a cable and get the spectrum analyzer set up, and we shall look at the spectrum analyzer output to make sure it's definitely doing what it's supposed to do. Right, the cable's too short. Let's go to the next size up. So that plugs that in. Now my spectrum analyzer's got a DC block and a 10 dB attenuator on the front end of it. They're always there. So it will be 10 dB down unless I do compensation for it. Okay, I'll set the spectrum analyzer up. I have trouble saying that. Turn this on. What we got? Oh, actually, this might already be set up for this. I think I might have worked on this last time. Yeah, I think this might be set up already from last time. So let's get the camera adjusted. So I've got this set up kind of. I'm going to set this up on my spectrum analyzer, which is up there, and I'll change the camera view to show you that. And the idea then is that I can demonstrate the RF output accuracy, hopefully, of this thing on the spectrum analyzer. And I know you can't see it, but I can. So I'll change the camera around, point at the spectrum analyzer, and I'll tell you what this is doing versus what we see on the spectrum analyzer. Well, the spectrum analyzer can do 30 dBm maximum, and this is 10 dB, 20 dBm. But I have the DC block and the 10 dB attenuator on there all the time, because you never quite know what's going to happen. You could put a piece of gear into it and it's got a DC bias on the output. You know, it could be some kind of fault when it's shoving DC out, so you've got a DC block on there. I mean, it's supposed to be tolerant of up to 50 volts DC anyway. A lot of spectrum analyzers are not tolerant of any DC bias whatsoever, so it's just a good thing to do is put a DC block and an attenuator on the front end, just to give you a big margin of error. So if you make a mistake, you don't blow your spectrum analyzer up. You know, it's just one of these things. It's just a good precaution. If you think you probably won't make a mistake, you probably won't get it wrong, you probably still will at some point. This is reflecting quite badly. Let me adjust myself here. Do away my chair. That's far better. Try and get it straight, you reckon? Right. We didn't get to look at the RF board. No, you didn't. There's too many screws in that cover. Oh, I wonder if there's any capacitors in there. Oh. Could there be capacitors on the RF board? I didn't think to look at that. Oh no, we might have to put it apart again. Damn it. Yeah, I might take the screws out and let's have a look. Okay. Well, let's start with this. This is set up for minus... Yep, that's all good. Plus 10 dBm top. Okay, I think we're... Yeah, I think I can do this. Let's turn the up and on, see if it comes up. Yep, it's showing up. Yep, it's definitely showing up. So that's all ready to go. Okay, let's do some video on this. So here's the spectrum analyzer. This is already preset to show the thing on the centre of the screen there. So I'll turn the up and on. This is set at minus 70 dBm. And it's basically right down in the noise right there. You can just see it peaking up there where the marker is. Just see it. So if I set the spectrum analyzer up differently, you could probably see it a lot easier, but this is good enough for now. Let's go to minus 60 dBm. There we go. And it's sitting around the minus 60 dBm point. Minus 50. And so on. 40, 30, 20, minus 10. 0 dBm, plus 10 dBm, plus 2 dBm. So as you can see, that's all looking fine. Now something I haven't figured out how to do on here, even with the markers, is to see what the actual level readout is. I mean, I'm sure I can do it, I just haven't figured out how to do it yet. I don't know, maybe I should read the manual or something. Anyway, so that's 0 dBm there. And I go down by 1 dB at a time. See, I step in quite nicely. Back down to minus 10, that's fine. I even do decimals, so that's currently minus 10. And I'll do minus 10.2, 0.3, 0.4, and so on. And bring it down, that's now minus 11. So that's working all fine. All the attenuate stuff is working good. So I'm happy with that. But yeah, that was interesting. When I did that just then, it crashed and rebooted itself. Was there a little firmware glitch just then? Did I just find a firmware bug? Let us repeat what I just did. I went from -10 down to -11 in 0.1 steps. Down to -10 and then down again. Got to -50 and crashed. I found a firmware bug. That's awesome. Wow, that's brilliant. Who would have thought you'd find a firmware bug after all this time? Yeah. So if I go -10 again, I'll just go in 1 dB steps. Oh, turning up and on. Right, so it's -10 there. To -12, back to -11, back to -10, back over, down to -50, -60. Yeah, it only does it if you do the 0.1 decimals. I'll do 0.1 decimals down to -11 again. I was going to see if I can replicate it one more time. -11, up to -10, or down to -10, -12, back to 10, and then back down to 50. No, this time I didn't crash. But yeah, I don't know. It looks like there's a firmware glitch. That's incredible. Anyway. Or there's something else wrong which I haven't noticed yet. I have to wonder. Anyway, I think that's done. I'm just going to watch it now with no output and set it at -70. Just in case it is something crashing and rebooting, or maybe there's a power supply issue which is not right. I'm just going to watch it. If I just turn the output on, if it reboots, it turns on with the output turned off. So just want to see what happens there. Nothing so far. Let's go -50. Let's leave it sitting there, see what happens. I'll just quickly go and get a drink and I'll come back. And hopefully it's still going. Hey, it's gone. It dropped out. Oh, that's interesting. Just when it's sitting there, it dropped out. So maybe it's not a firmware glitch. Maybe it's something going on. You might have more to do. Did I put a capacitor in backwards? I don't think I did. It's drawing 11 watts. Well, it's not impact sensitive, so it's not like vibration or bad connection. Then it rebooted. Interesting. Something's going on. It looks like I'm not quite finished yet. That's it, let's reboot it then. So I don't think we're quite finished yet. This thing's rebooting itself. So we know the output's working okay, so we need to get rid of this part. But when it's just sitting here, it's just done it again now. Let's reboot it again now. It's stuck. Something's going on. There's a problem still. Now it could be something I've done. Could be I've made a mistake or disturbed something. It's possible. So I'll get the thermal camera out and we'll see if something's getting hot. So we're sitting here for now, like that. Yeah, you see the screen, man. That's interesting. Take the cover back off again and have a look inside. I'll turn the upper on. That way I can see what's dropped out or not. Let's get the thermal camera, see if anything's getting warm. Oh, it's rebooted. Let's have a look, see if anything's getting hot. There is definitely something hot over there. $87 degrees. What is it? I think it's that capacitor, which is definitely in the correct way around. No. Where is it? I can't identify where it is. Oh, it's the bridge. The bridge rectifier is really hot. Okay. That's 85 degrees. So it could be something overloading the bridge. What's overloading the bridge? Oh, there's a chip down here which is getting really hot. 43 degrees. There's two of them. They're not too bad actually. 43. Although they're warm, they're not that bad. Okay. Yeah, the bridge is definitely getting very hot. That makes me suspicious. Let's unplug this and unplug that. Let's see if that bridge comes down temperature. Seeing 82. That is getting cooler. So wherever these two wires are going, did I get them on backwards after all? Did I? It's down at 79. I don't know where these wires go. I thought one went to the EL display, but it's still lit up, so I'm confused by that now. 77, still coming down. Interesting. sitting at 77 now. So it could just be pure loading on them, but I'm surprised the display's still going because I unplugged these two plugs. Can someone go back at the very beginning and tell me which one was which? Because I did make a kind of note, but I'm not completely sure I got them right. I'm pretty sure that the black and orange was the right hand one and the brown and white was the left hand one. That's what I remember, but I could be wrong. I think they're both the same thing anyway, but it may not matter. Let me just double check and see what's actually there. They might both be the same. Try this without shorting anything out. 5 volts on that one. 5 volt, yeah, they're both 5 volt rails, so it shouldn't actually matter. Both the same thing, which is what I thought they were. So that shouldn't be a problem. But it's getting hot. For some reason it's not very happy. Is my chat broken on here? Yeah, the chat's broken on the tablet. It's given up. It's not updating. Let's come over here and have a look. Come on, this onto the computer. Yeah, I'll do that for a bit. So it's not cut out again yet, but now I plug those two wires back in again. That bridge is definitely very hot. One of those capacitors is a bit dodgy, but they're not getting warm, so don't know. You might have to turn it over and look at the other board. Does it do any other frequency? No, it doesn't. It's only 30 megahertz. Missing paint on a transformer panel may be leaking RF. Yes. It's entirely that. Should have painted it. Right, I'll catch up with the chat, then I'll go back and I think I'll take the bottom cover off and just see what's under there. There could be something overloading it from the bottom side. Maybe it's the reason it was sold. Entirely possible, yes. This one I thought was done. Oh, Dave's gone. Thanks, Dave, for dropping by. But he's gone by now. The output's still on, so it's not dropped out again. Brown towards the back, great. Excellent. Well, you know, the shirt says it all, doesn't it? Right, I think I will pull the bottom cover off again, take apart the RF section, see if there's anything in there which we may have missed. And there's nothing sharp on the top apart from those two chips at the back, which are 43 degrees, which are about the same. There are a pair of chips which just look the same, and it's not that bad. So those look basically normal, and obviously the actual bridge rectifier itself. But for that to be running that hot, I'm surprised. You think the regulators be running hotter than that, and the regulators don't show up. So that's suspicious. Maybe there's an issue with the bridge itself. It is paint, yeah. Anyway, we'll go back to it and we'll figure it out. Something's going on. We can figure it out. I've got a service manual. I do have it. Might be only electronic, I can't remember. Might only have an electronic version of the manual, but I do have one. Yeah, that's the weird thing, is that those connectors, I'm pretty sure one of them went to electroluminescent display, but I unplugged it and it's still going. At least that's what I did on the other unit. Anyway, let's go back and carry on with it. And it still hasn't cut out again. The bridge is 80 degrees, so it did start creeping up again. Obviously, having the top cover off is allowing the heat to come out. Now it's been on for a while. I'm seeing some other stuff getting warm. Let's have a look. What's that? It's 45 degrees. It's not that bad. That's just the resistor over here. That's not that bad. Transistor there. Yeah. Those two chips at the back, 44 degrees. It might come up slightly more. Not much at all. The regulators, I think, it's a bit hard to judge. Can't see any heat in the regulators at all. It's just the bridge. Yeah. I don't know, I'm starting to wonder if the bridge is bad or one of those is a problem. But those capacitors aren't showing up at all. I thought if there'd be a problem with the cap, they would have started warming up, and there's nothing. Because that bridge is hotter than I think it should be. So we'll look on the bottom of the board, but the thing is, these regulators aren't even getting hot, right? So if there's a big load on, say, a 5-volt rail, for example, you think the regulators be getting warm as well. But there's nothing. You know, I can keep my fingers on them. The warmest one is the right-hand one, and that's the 5-volt regulator. And that's not surprising because most of the circuitry is 5 volts. So, and it's even not that bad. It's like there's almost no real heat there. So it's a bit weird the bridge is getting so hot when there's not really much other loading. Could the bridge be bad? So I'm wondering. Just wondering if I can actually measure it from the top. Probably can't measure it from the top. Not on directly on a bridge, but through surrounding circuitry, which may not be ideal.
So the AC comes in from over here, right? In fact, there's two bridges. You've got that bridge there and you've got this bridge here. So that's going to be trickier to do. Because they're going to interfere with each other. Now let's see what we can do. I'm not sure if there should be a short or not. It's a bit hard to judge it because there's been two bridges in parallel. Let's take the bottom cover off and see what's under there. We go from there. And I think I'm going to have to get the check going again on here. Come on, wake up. Well, I'm just wondering. Like I said, these regulators provide all the power to the whole unit, right? At least from what I can tell. So they're not getting hot. The bridge is getting hot. It kind of tells me that bridge is being overloaded. Well, that's why it's getting hot. But if the regulators aren't getting hot, why is the bridge overloading? None of these capacitors are getting hot. All the ones I put in are okay. There's no signs of them being overloaded. So, I mean, have I plugged something in wrong? I don't think so. It's pretty hard to mess this one up. So let's take the bottom cover off and see what's underneath the RF shield, eh? Let's have a look under here. So we find some tantalums or something. Ah, we can see the bottom of the board, not the top of the board. This could be a nightmare. I might have to take the entire module out.
back to the other camera so you can see a bit better. Loads of screws, which are all really tight, so they've never been opened, I think. I was thinking I might have to actually remove the entire module, not just a part of it. There's a screw right there. Oh, I did. Should I? Is that threaded in, or is that the bolt on the other side? Yeah, that's threaded. Just take the module out from here. I think I have to lift the whole module out. Actually, I'm going to take apart on this thing to get it apart. Maybe that one. There's a magnet gone. This is a pain. I will have to take the front panel off. Yeah. Take the front panel off. I think we need to look though. I mean, either way. I mean, we need to open this thing up and see if there's any more capacitors in there, because there could be. Do that. It's not good for it. I'll put that back on again before I forget. Any more screws were there? Oh, jeez. It's just getting smaller and smaller, isn't it? Don't damage your display. Do you know what? Maybe I could have just done this bit. Thinking about it, I probably could have taken this panel off here rather than the whole assembly. That could have been a thing. Maybe I could have done that bottom panel. Then I could lift this off. It's got a screw there which is loose. There's a screw there and it's loose. Oh, that's interesting. Someone's been in here before. Is there another screw? Where is that one? Which I thought I did before. No, that will come out now. What's the other side of that? It's sealed as well. Great. Okay. We'll take all the screws out one side, see what's on it, probably put them back in again. Do you think I should cover this in the video? I think I should do it. So I'm basically stripping this apart, trying to get this panel out because I want to see what's inside this section. In case there's capacitors or something in there which is giving trouble. Thermally I can't see anything else anywhere wrong. But taking the whole front panel apart, which isn't actually that hard, it just all falls apart. It's just like lots of little pieces. Now it's off, actually, it'd be a good time to clean it. But I'm going to take all these screws out of this panel here. I have to get this one out, which is why I take the panel apart. I also lifted it. Nothing on the other side. I've got to take all these out as well. Potentially, I think we're looking at the bottom of the board on this side. So, actually, what I might do is unplug it and work it on the bench. That'd be a bit more sensible, wouldn't it? Let's do that. Get this out of the way. Unplug this. Working it like that. Look. It didn't fall over then. Move my chair back in. Catching up with chat. Yeah, anyway, it seems to be working fine. I didn't have any issues with that. It seemed to be switching perfectly. So, anyway, we'll have a look. We'll take all the screws out and have a look at it. This screw's different to the rest, I wonder why. You might just fine, but take the side off and it looks fine. Without, you know what happened, eh? If I put all these screws back on again, we'll take it apart and go, oh, there's nothing there. Put the screws back in again, and then we take the other side apart and find capacitors. And then we have to go through and take all the screws back out for the second time. Yep, it'd be a moon, alright, so that's fine. Let's just have a close look at this. So there you go, we've got the bottom cover off. That's what's on the inside, on this side at least. That's all we can see from here. Nothing to see. Let's take the screws out the other side and see what's on the other side of the board. Shorter screw. The other one also had a shorter screw there too. Well, what I'm seeing though is an overload on the power supply. So I'm suspecting there could be a tantalum cap somewhere, which isn't the best. It may not even be on a main supply rail, it might be like a sub rail or something, but then it's all working properly. That's the weird thing, it's all working perfectly, apart from apparently overloading. So, I mean, if there's a tantalum, expect it to be a dead short and completely kill the rail, which in any case you expect to see some kind of symptom like it doesn't work. But if it's an electrolytic which is weak or failing, then you could easily get a partial short, or at least a very low resistance, which could then cause it to give a similar symptom, you know. Right. And there's ceramic caps in here. one electrolytic. So yes, we did need to come in here. Right. So that's the top cover off. Look at this. Lovely. So there's a crystal here, which is obviously this would be the oscillator section. It'd be the 30 megahertz oscillator in here. Let's get it slightly better like that. There you go. So it'd be 30 megahertz oscillator there of some kind. Then we have some amplifier buffer stages. May even be a POL system. I'm not quite sure. I don't think so though. Looks like it's too discrete. And then we have some amplifier stages here, and these are probably attenuator sections in some way. I have to wonder how it's doing the attenuation, because it does 0.1 dB steps, 1 dB steps, and 10 dB steps. So I'm actually wondering, how is it doing that? We've only three relays in here. Right, it's 3 relays here. Curious. Got to be careful not to touch anything. But there's one electrolytic cap in here. So yes, we did need to come in here because that cap will need replacing. But there's no tantalums that I can see. Nothing standing out as tantalum. There's ceramics. There's also one underneath there as well, interestingly. And that circuitry runs underneath this frame. Looks like there's not much under it, so I don't think there's any more capacitors than I need to worry about. So we'll replace this cap. Could that be the problem? Unlikely. I mean, yeah, it's unlikely that cap is the problem, but it's there. It's going to need replacing because to replace the other ones. At least then the whole thing is done. Don't have to worry about it anymore. But yeah, still puzzled about the overload. Just got a feeling I'm missing something. What I'll probably do is, once I've replaced that cap, is I'll plug it back in again, repower it, and see if anything is looking obviously bad here. Maybe something's not happy in this board, but then it does seem to be working, so I don't know. Should have painted the cover. Yes. Schematic. You want to see the schematic? Alright, let's desolder that cap. Should I put gloves on? I should put gloves on. But if I don't touch it, it should be right. I'm not planning on touching anything. All I'm going to do is get that capacitor, which is right there, desolder those pins, drop the new one in, solder it back up again, a little bit of IPA, give it a clean. I'm not going to be touching anything. Now, as that's just an electrolytic cap, it's not going to be too critical to see. It's probably some supplemental power supply smoothing, I expect. Ian's done his. Yeah, Ian told me he's doing a modification to his as well. He told me he was going to do it yesterday. So I guess he's published it already, is it? There you go. Negative that way. 10 microfarad, 25 volt. Negative that way, don't forget. The board's marked anyway, so it should be safe. And it's marked correctly. A good example, talk about the Adventist. that has actually got a known issue with a capacitor on that circuit board. It's mounted as per the markings on the board. The marking on the board is back to front. So you have to take the capacitor out and obviously replace it with a new one and turn it around 180 degrees. So this is where the whole thing of not trusting that the capacitors are correct comes into play. Right, so I've just taken this capacitor out. Negative goes that way. Let's test it. 7.8 ohms, 11 microfarad. It's supposed to be a 10 at 25 volt. 7.8, it's sounding a little bit on the high side. Let's get a new one. And we'll test what the new one is. What's this one here? That's 16 volt, I want to put 25 in. $35, good enough. Right. Let's just quickly test this one, see what this comes up as. $6. So it's definitely lower. It's got a lower capacitance, but usually because they've been sitting around for a while, they need a bit of reforming to happen. So it's probably come back a little bit better once it's been used slightly. So it's definitely better than when it was in it, which is the main thing. It's got a lower ESR, so we'll put that one in. There's a trick in your vid for the OLED brightness. I know that Michael T did mention about disabling the dimming circuitry. He mentioned that in the thread. I didn't try it. I mean, my display was very uneven anyway, like the actual segments, I suppose you call them. They were not what they should be. They're very uneven. If it was more even, just dim, I probably would have tried his, but because they're all over the place, it's like, no, I'm not going to bother with that. I'll watch your video later on, Ian. I'm sure I'll find it very interesting. I'll probably sit there swearing going, I wish I'd tried that, or something along those lines. Or, I wish I thought of that. Might get a cotton bud actually. I'd better use one of these. A tiny little pointy stick one. Try and keep it all from spreading out too much. Problem is they don't absorb much. They're good for getting into places like between legs and stuff like that, but they don't actually absorb that much. clean. Let's have a quick look over the circuit board, make sure there's nothing looking dodgy on there. There's actually flux around the relays. This relay here has got like flux around it. I'm actually wondering if I should clean it off. Maybe someone's resoldered it at some point. I'm thinking I should probably do that. Maybe I'll show you. So this very end relay here has actually got a lot of flux around there. I'm actually thinking I'm going to clean that off. It's almost like someone's resoldered that at some point. Maybe they had a dodgy connection or they replaced it or something. Maybe they replaced it because they somehow had a mistake. I'm going to clean that flux off because I don't think it should be there. There's so many little sharp bits here, it's all going to shred it, isn't it? Probably can't see what I'm doing anyway. Basically, I'm just trying to spin it so it grabs any bits which might be floating around and hopefully picks them up and takes them away. Let's have a look. So looking a lot better. Yeah, all looks fine. Let's put it back together. This is the really boring bit, putting all the screws back in. I'm going to just put one side together. The other side I'll leave apart for the time being, because it's possible that there's an issue and something will be getting hot. Now the circuit board side not likely to get hot, but the other side may do. So I'm going to assume that plugging in and testing it without the other side covered is a good idea. Of course, what happens is I'll put all these screws in and I'll find a problem. I'll have to take it all back out again. What do you reckon the chances of that are? I mean, it must be quite high, surely. It must be quite high chances. Yeah, Vladimir used to give donations before, eh? I used to donate before, but now you can't. Because of the issues that's going on over there. It's not like it's in your control, is it? So, yeah. So many screws. But then it's RF stuff, you know, it's going to be lots of screws everywhere. It's just the nature of it. The relay stuff was fine. I had no issues with the outputs. The outputs are working perfectly. Output's working perfectly. The issue is that one of the bridge rectifiers is getting very hot, and I wanted to look inside this panel anyway. As it turns out, I had to replace this capacitor. So looking inside this panel was a good thing to do, because it kind of needed it anyway. So I'll get the thing back on the bench in a second, and we'll plug this in, and we'll thermal camera check the component side of it in case there's anything going horrendously wrong on this board, which was not so obvious the first time around. Check to there, yeah, that's all good. Good. Right. That's those. So I'll leave this side open for the time being. And I can just sit this on top. I don't actually have to put it back in place. Let's get the thermal camera turning on. Takes a little while to boot up. I was actually thinking about getting hold of Keysight because I had an option when I got given this one to review. This is the W01. It's also W02, I think it was, and that boots up really quickly. I saw someone else did a review of it, and it's like, wow, that's really good. And that'd be really useful because one of the worst things about using a thermal camera is waiting for it to turn on. Okay. Power back in. I may have to reset chips as well. I mean, it's not exactly a big deal to do that. Okay. Just double checking everything before I power it. This one I find out there's a shorted wire on the end of the plug here. Right. That switch is in the on position, that's fine. We'll leave it there. That is weird the way this display could still be seen after I'd unplugged it. But you know, I unplugged those 5-volt plugs over here when I was checking for that load, right? The orange one, that's right, the orange one goes to the little VFD driver, which is basically a little transformer with an oscillator. So it's 5-volt, drives an oscillator, which then drives a little transformer, which outputs high voltage through a couple of wires, which come over to this end of the screen. So that generates high voltage. I unplugged that and the screen was still visible by the same amount. Maybe that driver is not good either. Well, I've done one of these screens before on the 2510, and I think I did a live stream, and I had to remount. I had to cut this post down shorter so I could get the thing to mount backwards. because I used a different display. Because it's a standard 2x40 display. But yeah, I'm just wondering now. In fact, I unplugged it and the screen was still on. Let's unplug that now before I power it up and see if the brightness changes when I plug it in. Maybe the screen is just reflective and that's why I can see it and you guys can't. I don't know. Right, let's turn this on. Make sure there's nothing in the way. Shielding. Give it a push backwards. Right. Let's record video. Right, let's see what happens. Turn this on. That lit up. That's actually running. Interesting. Just plug that cable in. Nothing changed. That's weird. The EL display is maybe not working. Okay, well let's look for hotspots. This is the whole point of this. I've got the camera out here now. And it's going to check for anything which is looking like it's bad on this circuitry here before I put it back together. Because it's all reflective metal, it's all shiny, which makes it a bit harder to find things which are hot because it's all reflecting off the surfaces in the room. But there's nothing flagging up. The bridge is up to 39, 40 degrees already so far. Yeah, it's already up to 41. It's still climbing. So this board looks fine. There's nothing getting hot in here. There's nothing getting hot in there. Let's look at the display side of it. Yeah, nothing on the front panel either. That's all looking fine. That bridge is just getting hot for some reason. I'm wondering if the bridge is faulty. Yeah, that section's looking absolutely fine. I'm happy to put that back together. Under here, there is like nothing. You see a transistor there lighting up. It's only like 28 degrees. That's nothing. So the resistor over there is 41. Maybe that's a clue. You've got a resistor running a bit warm over there. Maybe I should pull the circuit diagrams out and have a look at that. That could be a clue. But that bridge is still getting hot, so that's the only thing I'm seeing is the bridge and that resistor. And there's two chips at the back there which don't matter. So curious. And this thing is charging up. I should probably do that. There it is. I was wondering where it was. I was looking for it thinking, where's the charge port? I'll do it later on. If it goes flat, it doesn't matter. I've got a second camera. Stop recording. Okay, we'll put this back together then. So at least that bit's looking good. We know that much. Well, I might have to look at the circuit diagram and pull that up and to see what could potentially be there, because that's going to give us what we need to know. Don't like the way it's bending that way. Anyway, here's what it is. So I'm pretty sure I do have the electronic service manual for this. Boonton were good actually, they had diagrams and all sorts of stuff in theirs. So those ones are usually pretty safe. Get the screw in, here we go. So I'll get this back together and then we'll put up the service manual, have a look at the circuit diagrams, find out what that resistor feeds, because that's getting hot. Could be nothing, but it's maybe a clue, and also what that bridge is feeding, and find out maybe, if there's something I'm not seeing, because I'm not looking closely enough at something in particular. I'm comfortable this is fine. Because I mean that bridge is getting hot even without the output being turned on. I didn't turn the output on, did I? Do you think turning the output on will change anything? Now I'm wondering if I should turn the output on. No, it's getting hot anyway. I don't think it's that. I can always unplug it and verify, I suppose. It's just a shame that the side with all the components on is the side which is tucked away instead of just take the top cover off and just look into it. But, oh well, never mind. Would have been convenient the other way. One last go around, make sure I missed any. Right, happy with that. Let's put the manual up and have a look at that. Right, Boonton. Give me a minute, I'll change camera views and stuff in a second. Just, Boonton 5220. Right. So look at the board layouts first. So CR2 is one which is getting hot, and R9. Okay, so is it bigger? Right, so CR2 is getting hot in this corner, which is interesting, and R9. So circuit diagram. R9 is here. Zener diode supply. Okay, it's providing a Zener supply. So it's not surprising it's running a little bit warm. So it's providing a bias for that op amp. LM339 op amp. 10k across the other Zener, and we're dropping from an unregulated supply rail. Interesting. That's some CR1, not CR2. CR2 is over here. So CR1 is not giving any trouble, so that's fine. It isn't that loading down that bridge. So in fact, that's a Zener regulated supply running at 43 or so degrees I'm not worried by that. That's okay. And CR2, which is over here, is almost just getting hot. So that is running that big cap, which was previously leaky. Well, the one that's bulging, they had to get a cap on it. So that's feeding that regulator, and it's got an unregulated supply come up here. 3K, 1K, C22. It's got that across the wiper of that. It's going to an op amp though, so another 399. U24B. U24A. Same device. U24C. Oh, it must be a quad op amp. 339, yeah, quad op amp. Wonder if we should try replacing op amp. Op amps do fail. Maybe, I mean, it's 3K though. I mean, it shouldn't be loading it that much. 8 to 12 volt unregulated. And that's why this is the 5 volt rail. When I pulled those plugs off, the bridge started coming down in temperature because obviously that's off that particular bridge. So I replaced that cap. Replace that cap. These are all ceramics, but they won't be shorted because it would have shown up as being a problem, because I did measure that supply rail. It was bang on 5 volts, so it was fine. So I'm just suspecting what happens if that diode shorts. Now this is a protection diode for the regulator, right? This is quite a common technique. So you put a diode on the output to the input, so if you get reverse polarity, it protects the regulator. But in this case, it doesn't actually require it. If that was shorted, that'd be trying to pull the supply rail down to 5 volts or some kind of balance in that way. Yeah, that does go off to those. That's just the main 5 volt rail. Let me try and find some more circuitry here. There's 15 volt rail there. Main 5 volt rail comes into this device here. Just general stuff around the place. Main 5 volt rail comes into these. Unused gates of some device. Mind you, I didn't see any op amps getting hot, so maybe the op amp isn't an issue. It's just suspicious that that resistor's getting hot on the Zener supply to the op amp, and the op amp is also being used on this other rail. This makes me a little suspicious. U24. U24 is where? Drag the right thing. I don't see it. There's 23. We're close. 26. Oh, there it is there. Right next to that resistor. I didn't see that getting hot, so Yeah. Oh, thanks, David. You found it before I did. Well, the thing is, though, if that's yeah, come back down here. That diode is shorted. This regulator is going to be dragging the voltage down, right? So this regulator is doing all it can get this output to be 5 volts. So this regulator will be dragging the supply rail down, but because it's also got that offset between the input and the output, the name escapes me right now. That'll put it down lower. If I can measure this point here, CR5, if I measure CR5 and I see a higher voltage there, which is more like what this should be, then I'll probably be happy to know that at least that diode's not blown or leaky or something. It could even be the regulator is a bit dodgy and it's overloading. It could be shorting through the regulator down to ground. I mean, it's possible. Can happen. So all these chips and stuff I can pop out because all in sockets. So I could easily take every one of those chips out and, well, any one of them and replace them if needed. But I don't know. What if I check between pins 1 and 2 of that regulator and see what the resistance is? That might give us an indication it's potentially looking too low. Charging up a capacitor, which is always a good sign. 580 ohms in that way. Let's reverse it. And you're blind, so you can't see what I'm doing. And it's currently charging cap. I'll unlock the camera in a second. I'll do it now while I'm waiting. Yeah. It's going to take a minute. And it's still charging the cap back up the other direction. I mean, I could actually just feed 5 volts in to the connector and see how much current the circuit is taking. But then the fact the regulator itself isn't getting very hot is making me think it's probably fine. This is just charging a cap up. It's not heavily shorted, otherwise it'd be just charging really quickly. Let's do a diode check across here. CR5 is right there. Again, that's doing a charging up thing in that direction, not showing as a short. Doing capacitor, it's fine. And forward voltage drop 550 odd millivolts forward drop. Let's check the other one as well to be sure. While I'm in here, that looks the same. So does that one. So on the surface it doesn't look bad. It's just curious that this regulator is not getting hot, but the bridge is. I'm kind of thinking I need to take that board back out again and maybe look at changing the bridge. I mean, that bridge is only running the 5-volt rail. That's all it's running. It's just dedicated to that one regulator, which is, you know, it's a 1 amp regulator. Is it 1 amp or 1.5 amp? NM340TS. Is that 1.5 amp or 1 amp? I don't remember. Usually 1 amp, but it can be 1.5. Could there be an issue with that bridge? Well, that's the thing. One corner of that on the AC input was getting warmer than the other side. Which is also interesting, right? If it is even around the whole thing, if the whole thing was getting hot, I mean, it was all fairly getting warm, but you know, there's obviously going to be some transference. But as more one side was getting hot, which again makes me suspicious. I'm going to take this board back out. It's not a big deal to take it out, it doesn't take long. So we'll do that, put the board back out and see what we get again once we've done that. Where's the magnet gone? I might take that bridge out and just see what that comes up as. Out of circuit. And I've got to take the side panel back off again. You should get that feeling going backwards sometimes. Anyway. Could be one diode short, exactly. It could be a bridge failure, and it could just be that one side is gone, and it's it could even be that one diode is going to open circuit, and so it's putting more stress on the other diodes to try and make up for it. You know, so being a full bridge rectifier becomes a half bridge rectifier, and it don't work so well. I mean, I could have probably scoped it and checked it that way too. That could have been an option. Fine, we'll do it this way. It's not a big deal to get this thing out. It's a shame we get to as far as getting it all back together again, and you've got to take it apart. And now I've got thermal grease everywhere. Right, let's check this thing on the bottom of the board. Should record the video, I suppose. Right, I've taken the board back out again because I want to test this bridge to see what's going on there. Let's try and pop it up so you guys can see. So those two there are the AC, those are the DC. So I should be able to measure from one side, whichever side's the negative side or positive, I don't know. That's charge up capacitor and it's reverse biased. And that should be the same, it is. This should be the same, should also be reverse biased. Yep. And so should that one. Yep, that's looking promising. So it means this will be positive terminal, this will be negative terminal. Diode junction, diode junction, diode junction, and diode junction. It looks fine. Which only creates more questions because it appeared to be that it wasn't happy about something. Dust off the laptop screen, or the tablet screen, so I can read it a bit easier. Right. I mean, you could desolder it, be absolutely sure, but in circuit it looks fine. There's no shorts, and all the diode junctions which I expect to be there are there. So I don't see a problem with it. I mean, it's just powering that cap. I mean, did I put that cap in backwards again? Oh, no, I don't think so. Let's check. That's the positive terminal there. Positive terminal. Yep. Capacitors in right around. That's not an issue. I said it wrong in the fan before. I just realised when I was doing the diode stuff, I said it backwards. I said that as a positive. That's not. It's negative. That's a positive. Because I was checking diode drop through the junction of the diode, so I had it backwards. Well, what's going on? Why is it getting hot? Just going to have a look at the circuit diagram. See any other clues on there. Only showed up under load. Resistance across the bridge. Yeah, we can do that. Charge on capacitor. It's in the kilo ohms so far. 600k. It's not looking horrendous, is it? It's dropping though. 400k. It's obviously charging up caps. Well, the fact that that bridge, maybe the bridge is just failing. I wonder. Maybe it's when it's yeah. Maybe it's because it's so hot. It's opening up inside, breaking circuit, cools down, and comes right again. And so it's cutting off power because it's the 5-volt rail. It's the 5-volt rail which is dumping because it's resetting. I think I should just replace that bridge. If I've got one. My bridge rectifier. Footprint appears to be about the same. Chip markings. Yep, that looks suitable. Anyone want to look up the numbers, see if it finds out whether it's got a high enough current rating or not? Don't think it's only running a regulator and not much else. So KBP C605, and I've got any stuff on my tongue, of course. touch the heatsink. There you go. That's what I'm going to put in, is that thing. So I'm going to look that up and make sure that it's got a high enough current rating. KBP C606. This saves me doing it. It's quicker for everyone. Well, that bridge tested as okay, but I'm suspicious about the temperature being so hot on it. I mean, they can get hot. They can just be the way they operate. Sometimes you do get a voltage drop through the bridges, and it is quite normal to get some heat, but it seems excessive, and especially with the actual the voltage regulator is not getting that hot, and it's only running the 5-volt regulator, and the 5-volt supply is one which is cutting off and rebooting. So I'm leaning towards a bridge being the fault. So I've got another bridge just here. It's probably fine. I mean, it's only a 1-volt, was it 1 amp, maybe 1.5 amp regulator. So I'm pretty sure this will do it just fine. And we'll see. It's an international rectifier version. It's rated 6 amps. So I guess that's what the 606 means at the end of it. Probably 6 for 6 amps. So we'll pop this one out, pop the new one in, put it back together and see if the problem goes away. I mean, we don't know for sure that's what it is, but it's a pretty high likelihood the bridge is what's at fault. I've seen bridges go, failure mode quite often. That does happen, but it's usually the small round ones, because they only rated like 1 or 2 amps themselves. I think maybe 3 amps, can't remember. But they're only really small round ones. Those ones fail a lot. I've had to replace a lot of those. This type usually are pretty good, but something's not right, so let's just pop it out. Okay, get the desoldering iron warming up. Should probably turn it on before I start waffling actually. Yeah, I mean it's only running its regulator, so it shouldn't really be getting hot. It could have some internal leakage even. It could be an internal issue where it's shorting internally, which is then causing it to get hot. I mean, who knows? Anyway, we'll pop it out. It's actually marked positive negative on the board as well, which is great. It means I won't get that in backwards. Well, probably not anyway. You have to wonder why using such a big rectifier actually. It's only got a maybe at most 1.5 amp regulators running. Let's go back to the circuit diagram from that. So have a quick look at that. In case I'm missing something, I don't think I am. It's only going to the feed of that op amp, so that shouldn't be much. I mean, it's going through a couple of resistors, so that is not a big loading on it. Yeah, there's no reason for it to be as big as it is. I guess I just designed it with a big overhead. So, that's fine. Yeah, I'm out of shot, aren't I? Of course I'm out of shot. Yeah. See? Easy. Get one of these. It's so much easier. Right. Put the new one in. The correct way around. I even might space it off the board a little bit instead of leaving it pushed right down like the other one was. Just very slightly raise off the board, because then I can actually potentially probe it if I needed to as well. Also, if it gets hot, it means it's not putting heat straight into the board. Gives it a bit of a chance. Bit of an air gap. Come on, solder. The leg's being a little bit resistant because they're sitting around for a little while. Make sure it's straight. Ish. Don't be wonky, you, eh? And I forgot to turn my extractor on again. Jeez. Spend a lot of money on an extractor and I keep forgetting to turn it on. Both 6 amps, 7 peak volts. Okay, alright. Right. So that's replaced now. Yeah, all soldered up. Looks nice. I slid it off the board a little bit instead. Last time it was flat on the board, this time I've raised it up. So it means now, if you need to from the top side, you can actually probe the bridge from the top side of the board. The other thing, it also means that if it is getting hot, it's not putting heat straight into the board, and it helps it to make sure it doesn't damage the board. But the fact there's no like dark staining on the board already means there's a good chance that this wasn't getting hot originally. So yeah. No flux outside. See if it looks like it's soldered okay both sides. Ish. I think this side could use a bit more actually. A bit of solder on here. I'm being too fussy? Yeah, probably. But if you've got pads on both sides, I like to make sure that they're all soldered. Yeah, that's definitely both sides now. I know you can't see what I'm doing because it's all blurry. There you go. Soldered that corner, because they weren't soldered too well on the top side pads. Well, it did seem to be a firmware glitch. The way it's repeatable, it did it exactly the same way 2 times, and it did it exactly the same. So maybe it is a coincidental thing with the timing. I don't know, but could have been. Right. Let's put this thing back together again and see if it works this time. I mean, I'm also half tempted to take that 7805 regulator off and replace that too, whilst it's apart. I'm so tempted to do that. Regulators can fail. But I've got no reason to see why it would. Let's do a little quick board inspection in case maybe I've bridged something or not done something very well. Well, it's all looking okay so far. I can't see anything. Well, a couple of dodgy solder joints though. We'll touch those up slightly. A couple of pads here with not much solder on. Yeah, it all looks fine. Yeah. Let's put it back in. I don't know, do you reckon I should change the 7 out of 5 as well? I think I should just do it. Injecting power? Yeah, we can do that. I can inject straight onto the bridge and see what we're getting. Let's do that. Reset socket and ICs, yeah, that's something I can definitely do. Let me grab a probe here. I think 30 volts is going to be a bit much, eh? Let's go down to, I think it said, was it 8 to 12 volts, didn't it say unregulated? 8 to 12 volts on the output of that bridge, so we'll go with that. Got a 1 amp current limit. Let's plug this into here. Let's turn the power on and see if it maxes out the current limit. It's doing 200 milliamps. 200 milliamps. $200 milliamps shouldn't be getting a bridge hot. Yeah. That's nothing. Yeah. I reckon that bridge must have been bad. What we could try, AC side there. Let's inject power into the AC side of this bridge and see what happens. Nothing. Okay, let's do it into the other side of the bridge. Nothing. I don't know, it's not leaking. Don't know. But it's only 200 milliamps current draw, so that shouldn't be getting that hot. Mind you, I don't have the other stuff plugged in, so in fact I don't have these plugged in. We can check those too, can't we? I can check those individually. Negative side, the bridge, yes, and I'm using the wrong probe. So negative is that side. So I inject into these, which is the black on that one and the white on that one. Great. I inject 5 volts into those. And see what we get. Try not to short it onto the chassis. That's doing 60 milliamps, that's nothing. That's fine. Check the other one. Whatever that's powering. 10 milliamps, again nothing, that's fine. Yeah, there's nothing really obviously bad there. Curious. Let's put it back together, see what we get. Yeah, that's right, when the caps, even though it was definitely bulging and bad, it was measuring okay. So, you know, yeah. Let's put it back together. What I'm going to do is plug everything in, apart from this. Interestingly, that plug could go in 2 places. It could go there, or it could go here. It doesn't, but it could. Everything apart from that RF section is plugged in. Let's put some screws in so it doesn't move around. Then I will inject power again, I think. Now put that cable away, of course. Why am I being too fussy about this? Maybe I should just boot it back up again and just see what happens. Yeah, that's right. That rectifier was that cap which is bulging. So that cap which is bulging was on one which is giving us a trouble. I mean, that seems a little coincidental for my liking. It could be nothing, but it's just a interesting aspect, I suppose. Come on, get the magnet. Struggling with this. Come on.
I mean, something I haven't actually done is measured the voltage going into that rectifier. I mean, it's possible maybe the voltage from the transformer is too high, and it's causing an overload because it's got a lot to sync. But you think then that would affect both of the bridges because they're both, you know, in the same situation. They're coming from the same supply. So I don't know. I'm glad that they've used the same screws everywhere. Makes it a lot easier to deal with. I think I should just plug it in and just try it again as it is and worry about anything more diagnostic if it's not solved. Have I missed anything ever? Hope not. Okay. Get the thermal camera going again, which is almost flat. I might get the cable from here. And you've gone blind. So that's everything plugged in. Just double checking. That's in. That's in. That's in. Yeah, okay. So everything plugged in. Something I might actually do as well is measure the VFD voltage here. VFD. It's not a VFD. The EL backlight voltage here. I'm suspicious about that. Because plugging it in didn't seem to make it any brighter, so maybe the backlight is actually gone. It wasn't the other one I had. Anyway, thermal camera's ready to go. Let's boot it up. It's drawing less current. It was drawing 11 watts before, now it's drawing 9. I can still see the bridge, but I can actually see the individual diodes inside the bridge now. I can actually see 4 hotspots rather than one big hotspot. And it's only about 40 degrees so far. I think that bridge might have been the problem. Let's turn the output on and increase the level. Let's do like 0 dBm in case it changes anything. Power is still 9 watts. That didn't change. Bridge is still only 42 degrees. Yeah, I reckon that bridge was bad.
Yeah. So we're looking the same as it was before. Resistors 39 degrees. Bridge is still 46 degrees. It's not getting hotter than that. It's not shooting up despite running everything like it was before. And so the power input is now down from 11 watts down to 9 watts. Yeah, 11 watts down to 9 watts. So it's definitely dropped power usage as well. That bridge must be faulty. But I'm thinking that the backlight isn't working. Unplug that. Oh, it did dim. I don't know if you can see it on camera. It did change slightly in brightness, but hardly anything. See that? Yeah, that backlight's not good. It's still readable enough for me, so I probably won't bother with it. It's not hard to get this thing apart. What is hard is cutting his post down and remounting the display. I do have a display to put in. Yeah, it's just a case of cutting down his posts so I can actually get the thing in there and get the heights right so it sits nicely on a panel. That was a bit tricky last time. Yeah. Anyway, I think I should do some video on this. I've done some screenshots with this. I clicked the photo button on it to grab some screenshots. I should have done it before I fixed it, actually. I should have thought of that. Well, that pot there, that's for the contrast of the display. So that doesn't help the backlight part. It's only purely for contrast, and it seems to be set correctly already. Okay, let's do some video on this. So I've replaced this, as I've shown already, and the power draw from the main supply is down from 11 watts down to 9 watts. I've got the output turned on doing 0 dBm, so it's actually working and doing something. And that bridge now is barely warm. It's like 40 degrees. So I was looking at it on the thermal camera here, which is going flat, so that's what's on charge. That was about 43 degrees, I think it was, last time I looked at it. And that's been on for a while, and it's not getting hot. I can leave a finger on that. So that's fine. It seems that I was dissipating an extra 2 watts into that bridge. And this is everything plugged in, working. That should all be doing its thing. So I think I'm actually safe now. It hasn't rebooted again. It may not do it until I actually put all the covers on and gets, obviously more heat around it because it's enclosed. But I think that was it. A bad bridge. Pretty confident. Let's spin this around a bit. I can get to the connections so we can measure the voltage on the EL backlight and see what it's actually generating. Hope you can see it, because I can't, because I've got light reflecting. There we go. Right, let's stick that probe in there and that probe in there. 140 volts AC. So, I mean, it's obviously generating high voltage. It's just a bit weak, which is what happens to them. The luminescence fades off on them and they just don't work so well anymore. Anyway, it hasn't cut out. Still going. I think we solved it. Let's put it back together properly. through there, doesn't it? Yeah, so it sits down there like that. That pops through there to go to the front panel. Got the main board. The tricky thing is, do I then find that I've got some extra screws at the end? How many extra screws do I have right now? I don't know, because I've got to put the front panel back together yet. Yeah, I don't know. I guess we'll find out. If I don't have any extra screws in of it, we're good. I'll come back. These screws are barely magnetic. Turn the soldering on off anyway, get rid of some of the noise. Shouldn't need it now. Choppy screws on the floor, doesn't help. There's one goes in the front here as well, which was loose before when you pulled it apart. Where's the hole? That one. Is that one tight still? Yep. Anyways, I've just fixed it. Hopefully. We'll find out soon. Obviously when I get it back together, which won't take long, then we can leave it on soak for a little bit and see if it does the same thing. I'll do that thing with the stepping the voltages down and see if that is actually a firmware glitch or if it was purely because of the thing rebooting and it's purely a fluke with the timing. Which I think is probably what it was. I think it was a fluke of the timing. That's all done. That's in. That's down. Done. Let's put the front panel back together. Yeah. I think I need to put the sides on first. I think I do. Something like that, yeah. Right. I think the bigger screws were for the sides, were they? I think they were. And it's pressing on it, I've got to lift it up. The bigger screws are the side panel pieces, and then the smaller screws were for the top and bottom panel pieces. And then we've got the side panel pieces. Should I get the side panel piece out of the way before I get confused and have all these extra bits? There'll be one less, so it'll be the same as that, alright? They've been taken off. Okay, thanks for having me, John Boy. Yeah, all the RF stuff is done. I already did that separately before, so I'm comfortable. I'm comfortable that they are okay. So at least it wasn't just ending up a capacitor replacement and a bit of panel beading. It was actually something a bit more interesting than that, which is good. That's unintentional, but it was good to turn into something a bit more of a troubleshooting exercise. And actually a bit of logical thought going on there instead of just capacitor replacements, you know, which, you know, it's not necessarily the most exciting thing in the world, is it, replacing capacitors? But some people get quite excited about it. Right. Yeah, I'll do it that way. I don't think I've got too many screws yet. I think we're okay so far. Are those right around? Or do that supposed to go the other side? I think that was right. I think that was straight around. Definitely right. This one's got some extra bits on it, you see. I'm not going to tighten them yet, I'm just going to get everything in place. So, I've got these other bits of panel, and I was going to give this a clean, we'll put it back on because it's easier to do it now. Let's do that now. Now it's got nothing in the way. Little bezel bits sticking out. Look like a lot of East German devices from the 70s, really. Okay. Well, it's also very similar to some of the HP stuff. That is done in a very similar way. I mean, who knows who copies who? I mean, maybe HP copied it from the Germany stuff. Who knows? It's possible. Okay, that's definitely a lot cleaner. Put this bag on. Then we've got this piece and the top and bottom, then we've got this other piece. Let's do this with it. I don't think it matters which way around that goes, I think it just has to be in there. So we'll drop that on. I'll put it back out. Easy to put it on. Give this piece a clean as well whilst it's off. It's not too bad though, it's not like the bottom piece. It's got a little bit of residue just here, but not much. Well, if I was really worried about the aesthetics, I would have painted the back end of it, wouldn't I? Sure, someone would have told me if I'd done that wrong. I'm sure it's sitting in there right. It's got some sitting on it, maybe. sure that's actually correct. Is that just... yeah, it's just resting against that, that's fine. There's nothing wrong there. Okay. Just one making sure that it wasn't supposed to sit around those little bits that sit on the sides there, those little posts. So, it's fine. Top panel, bottom panel. Bits of foam in there, which I think are supposed to be sandwiching it a little bit. Just trying to show you, it's supposed to. I think it's supposed to be inside the slot a little bit, like this one. This one's pushed back. Oh no, it's fallen off completely now. Yeah, maybe I'll put that one on the bottom afterwards. Well, this one's done the same thing. I don't know. I just don't think that's sitting right. This middle bit just doesn't seem right. Is that supposed to slot into it? Maybe it's supposed to slot in, not sit on the side. Maybe that's what's wrong. Hold on. Where's that screwdriver gone? Here it is. That's what I'm wondering. Right now it's kind of sitting on the front. This doesn't seem right. Yeah, I think it slots in. That's what it's supposed to do. Okay. So this is supposed to slot into here like that. That's much better. Okay. That makes much more sense. There we go. That's better. That's how it's supposed to be. Didn't think it was right. And I'm not going to put it on the regulator again. I'm not going to put on a spectrum analyzer again because the output was fine. It wasn't actually misbehaving, so I'm not worried about that part. I think it's okay. It was just that regulator, the bridge. That's what I'm looking for. The bridge was the issue there. That's what it was, just overheating. That's what I was worried about. The actual output was fine. I had no issues with that. It all looked stable apart from the cutting out, whereas because the bridge was opening up, I think, and cutting power. And replacing the display is something I should do. I mean, I don't know, maybe I'll do a follow-up video about it later on or something. But say right now, I can still read it, so I'm not too worried about that. I can sort of wedge that in. Maybe. Just
wondering about this phone, whether I do something with that or not, whether it actually really matters that much. Yeah, it's got some play there. I think I will put that in. Or should I just put some new stuff in? I've probably got something else I could use. This stuff's a bit slightly thicker, double-sided, but I just want to take the double-sided adhesive off. I'll just stick it in there like original, like that. And there you go, just do that with it. That's better. And I don't seem to have too many extra screws, so that's good. Also, I need to power this up again at the end and just make sure it's definitely all still working with the covers on and behaving like it should. Obviously last time it didn't really shove it as a problem until it had a chance to heat up from having the covers on it, so it means I need to kind of give it a chance to actually do that. Would be nice if I'd identified the ridge was a problem before I put it all back together though. You might. That's there. Nearly there. And there I was thinking this would be a nice, easy, straightforward thing to do, and it's going to be a really easy, simple fix. A bit of panel beading, a few caps, an hour's work sort of thing, a couple of hours work maybe. Yeah, it completely worked out that way, didn't it? Double check everything's definitely plugged in. No, that's not plugged in yet. Plug that in. Yeah, it's a shame I can't do that EEPROM right now. It's not a big deal though. Okay, let's retest. Final testing. Right, I've got it back together. Let's power it up again for the last time and see if it continues to behave. Output on, increase the output, decreases the other way, decreases usually up, 0 dBm, and we'll see if it cuts out or not. You can still see it on screen. Maybe I'll get a bit closer, make it even easier for you. If it cuts out, you'll see it flicker. Power is 9.4 watts right now, which is good. That's kind of in line with what it was before we did the previous testing. So let's leave that powered up for a little bit and see if anything goes horribly wrong with it. I don't think it will. I think we're pretty good now. I'm just preparing all the parts for a photo. Just,
want to show what got replaced. Oh, it's still on. Right. Leave it on that shot for a little bit. And the chat on the tablet has died again. All these comments here which I haven't seen. Oh, what have I been missing? Oh, Rob's gone. Okay, that was a while ago. Comments looks like they've not been going for about 10 minutes. Great. I love how reliable that is. Yeah, the spectrum analyzer noise floor is like -70. I had it on there. Because the way I got it set up, it's not as low as it could be. Can I work on painting the rear? No. If I don't show you the back, it's fine. It's painted. I painted it when you weren't looking. How's that? You missed it. You looked away as I painted it. Painted plenty of time to paint it dry. Yes, okay. But then I would have not been able to put it back together, and we wouldn't have seen this whole second part of the video where the rectifier was an issue. You know, you guys wouldn't have seen any of that because I'd have painted it, put it back together, and then tested it later on, and then found that issue later on. Anyway, it's still going. This is 50 ohm output because it's RF. Well, you're still getting 75 ohm RF, don't you? But this is 50 ohms. Don't assume it's transmitting. You'll check it. Needs to be inspected. Fine. Well, I'll get the spectrum analyzer going again. Whilst you're waiting for it to die. I know you're all right. It's not glitched yet, as long as it's gone for so far. Yeah, it still says 0 dBm. Still working. -10, -20, 30, 40, 50, 60, and 70 down in the noise. Where's my mouse gone? There we go. Amplitude. So I'm turning the internal attenuator down to 0 dB. Now let's put the noise floor down to -100. I'll show you that, I suppose. It still hasn't cut out, obviously. And I'm still recording. That's boring. There you go. You can see that. Is that great? There you go. It's perfect. See? And I suppose you don't want a reflection either. Yeah, how's that? So yeah, -70 dBm. No worries at all. 60, 50, 40, 30, 20, 10. let's bring the attenuator back down. I'll do 20 dBm. And that shifted everything up. Now my reference level's wrong now. I could just type it in. I think I'll just type it in. And 0 dBm plus 10 dBm. Also reference level 20. And there you go, 20 dBm maximum. So no worries there. All working as expected. So I'll do 30 there, and I'll come around to digits again. 29, 1 dB at a time. Yeah, that's fine. And I'll do the same I did before, which triggered what I thought was a firmware glitch. Down to 11, 12, 10, and then go down to that in the noise. Yep, that's still behaving. No firmware glitch, it's all working fine. So there you go, it's still working fine. I just thought I'd show you on a camera here. Here's the signal generator output, well, the signal output into the spectrum analyzer. 20 dBm maximum, so that restrictions. Yeah, I might try and get rid of them. There you go. Right, so 20 dB max, all the way down, 10 dB at a time, down to minus 70 dBm, which you can still just see the noise there. And I've done the 1 dB and the tenths of a dB steps as well, and they're working fine. So it looks like it's well and truly fixed now. So there you go, that's what I took to fix it. All those parts and a thermal camera. Yeah, I mean, the thermal camera was a nicety. That's what really showed up what was going on, because it's a nice quick way of finding something which is getting hot. You can also go around and do things like touching with your fingers. Now, obviously when you've got mains and powered equipment, that can be troublesome. If you touch things which you shouldn't be touching because it's mains powered, you have to be careful of that. But in most cases, things like capacitors and these things, they're usually okay, but not always. So if you are working anything like this, think about what you're doing. I do not want to have anyone get electrocuted because I touched the wrong thing on a piece of gear. I always say gear. I don't want anyone getting electrocuted because I touched the wrong thing inside a piece of equipment and had a bit of a bad day. I don't want that to happen, so I always have to sort of say, be careful what you're doing. Anyway, this seems to be fixed now. I'm happy with that. And I'm very happy with that. That's definitely working well now. So, job done. Don't forget to subscribe over there. Other videos to watch down there, other repairs, and the Patreon support link over there to help you buy bits of gear like this to make videos about. Catch you later. Also, there's a thanks button down there too. If you want to just do a one-off thanks thing, push that. Look, it's about there somewhere. You can push that, and you can do a one-off donation if you choose to. Okay. Right, that's the video done. I'm going to leave this on charge because that needs charging up. Haven't charged it very often. I think I've only charged it once before in the whole time I've had it. Lasts quite well. And the chat on this bloody tablet is completely frozen up, so I can't see anything anyone's saying. Useless thing. It's better than nothing, but still, I'd rather have it working. Come and sit over here. See this chat. Okay. What did I miss? If you hadn't been here to help me, it would have taken it in half an hour. Yeah, well, that's the thing with doing videos. It does take longer, and especially live streams, because it splits your attention from that bit there and focusing on the details versus trying to communicate with you guys and read the chat and deal with the tablet, not updating chat like it's supposed to, and cameras, and there's so many distractions from it that it can make it a bit more tricky. I've missed a lot of chat. Yeah, just trying to catch up now. RF paint, yes, RF paint would have made all the difference. Send someone down to NZ to check if it's really painted. You'll never know. I just had to make sure I'd never show the back of that unit ever again in another video. It'd be like Schrodinger's RF calibrator. Is it painted? Isn't it painted? It's both is and is not painted at the same time. Right. Just scrolling down. Hey Chris, I don't know if you're there. Yeah, the noise floor, but that's because I changed the level. So to get the plus 20 dBm level for the upper steps, I have to change the reference level, and the attenuator, although set in the manual range, is affecting that range. So I think the most dynamic range is about 100 dB. I think most you can get out of it. So if you set the reference to 0 dBm, and then you give you a minus 100 dBm level for the low noise floor. So it's something like that anyway. Is it 97 or something like that anyway? I think it is. So you have to shift the whole range up and down with reference to the reference level and the attenuator level. So that's why it all shifted up when I did that other change. A few people have left since I wasn't looking. Yeah. Still catching up. Oh, it's still running. Black electric tape, yeah, that'd be the way to do it, eh? Just wrap it in tape. Bit of gaffer tape, something like, duct tape. Stick duct tape on the back. Bit of spray foam. Change scaling, yeah, well, I don't know. This is what I was working with. Yeah, that's a bit of spray foam. Just cover the back in spray foam. Yeah, just double checking it now. One last look at it before I turn it off. Still looking fine. Yeah, no issues there. It's fixed. Definitely fixed. Let's take a picture. And get the RF cable out of the way. Try and get the RF cable out of the way. Maybe some clutter around the back will be good too. Try to give us some clutter. I think I might leave the thermal camera in shot because that's relevant. Just give me a second, I'm nearly done. Photo. Done. Now we can turn it all off. It's good. It's fixed. I declare it fixed. You have a successful repair. Yay. I know you can't see what I'm doing, but it's not exciting. Okay. Excellent. Take the film to the drugstore. Yeah, one frame at a time, eh? How many frames? You know, if you've got a few hours of video footage, then it's 25 frames a second, 3,600 seconds in an hour. Who's got? Oh, I can't bother doing the maths on that. There's a lot of photos that cost a fortune. Anyway, that's all good. I'm happy with that. Just my photo. Oh, right. Yeah, that'd be a thing, eh? Just the cover photo for the thumbnail. I always take a photo for the thumbnail, well, almost always. Sometimes I forget. And I don't always end up using them. Sometimes the one that YouTube suggests is a good picture. I end up seeing that one as like the suggested thumbnail. It's like, yeah, actually, that's not bad. It will do. That's why if you see ones where I don't have any text on the photo, on the thumbnail, there's no text or anything on it, that's one which YouTube has probably generated, most likely. Yeah. Smile. Something like that. Is that right? Add that for the thumbnail. Oh. Right, it's gone 1 o'clock. It's at say 5-hour stream. That's scary, yeah. The mad professor here helps. I think I'm due for a haircut. I was going to cut it last night, but I was too tired after the other live stream. So, right, I'm going to call it a day. Go and have some lunch, have another coffee, tie up my desk, and maybe edit some videos, or maybe post some GPIB stuff. I'd sit down and read Ian's notes, and maybe I'll do that. I don't know. See how I feel. First things first, lunch and coffee. So thanks for dropping by. Give us a thumbs up before you leave, and I'll catch you another time. I don't know when the next live stream will be. Not sure. Depends on the mood takes me, I suppose. In fact, I did 2 in one day. Well, 2 in case of 12 hours. I don't know. I think you had your money's worth, eh? Didn't cost you anything. So, yeah, you definitely had your money's worth. So, catch you later.